and we'll get things moving ahead. So I'm going to go ahead and share my screen. So you guys should be able to see that okay? It says you can, but you know they lie sometimes. And
All good.
okay, good deals. So what we're going to look at is, first of all, did everybody get the materials? I gave you a download link, so you were able to get the sample files and the training guides. Everybody got those okay?
Yep. Yeah.
Okay, that's good. All right. So a couple of things we're going to be referring to. There's a couple of examples, say, in this particular training guide called the Civil, and this is what we use for the actual civil class itself. But there's some, some grading exercises here that we're going to go through, and they talk about, they get the right places, laying out a building pad in a parking lot, and how what do you do when you try to tie these things together, and how to resolve stuff like that. Some road design, things in there. So we'll refer to this one from time to time and that, but it's not really, a straightforward run through of what we're going to be doing today as a process. The other one that's included there is a fairly, uh, well, I say fairly extensive, so which, of course it is, but you may notice the date on the at the bottom there, July 20th, 2016. So it hasn't been updated in a long time. Um, and there's 829 pages here. And this is what Carlson put together several versions back of their takeoff product. This is their user's manual. And it starts out, if you see here in this first table of contents, little introduction, how to register the software, and then it goes through every command on every menu all the way through, and it's all, just documented to the end of time. What we're going to be looking at, if any, is going to be in this last page from the contents, this tutorials menu. And there's a couple of tutorials in here. There's a how to take a CAD file to generate these surfaces start to finish. We're going to be going through a lot of that stuff with that same type of with that same type of data. We're not going to do it exactly the same way they do it here. I'll show you some reasons why when we get to it. And then there's some road designs, drill holes, trenching, and then this digitizing. Is anybody still using a digitizer?
We are actively trying to sell one on Facebook Marketplace.
Yeah, I've got one in my garage too. Uh, so, uh, but this cute little story. Bruce Carlson, the owner of the company, and he got things started in the 80s when he was starting to sell this software. He loves getting out and talking to customers, and he still does that to this day. And he look when Gatico came out with their roll-up digitizer, remember those? He was giddy, and he bought one, and he would throw it in his truck, and he would drive around to all these mining companies and engineering surveyors. And let me show you this, and he would roll it out on the hood of his truck and show how he can digitize stuff right on the job site. Oh, isn't that cool? Yeah, Bruce, it's cool, but uh, we're past a lot of that. So anyway, I wouldn't waste any time in here, although it does have some things like digitizing these existing contours and how to set up this, how to digitize that parking lot. Obviously, we're going to have a PDF file or a drawing file already done. And if it's a PDF file, we just simply need to tell it what it is. Or if it's a scanned PDF file or even a scanned image, then we can draw over top of that image right on the screen, what we call heads up digitizing. Okay, so it's not really one of the more important parts of this tutorial exercise, but you do have this one starting here. We're going to go through a lot of that. And again, somewhat different in places. And they don't, for instance, and I'll tell you that as part of this, um, when they model this, there we go. When they model this site in Takeoff, they basically just model up to the edges of the parking lot here and they stop. Well, that's okay in terms of how to build from the back edge of the curb inward, but what do you do with, you know, the you're either underground or you're sticking up in the air outside that edge. You got to tie that back down to the existing ground. Well, they don't bother to address that. So, it's just little things like that that we can, take a little bit of extra thought, and it doesn't take much extra effort. So we'll go through those kinds of things. And then the other one is and get to the next. Example here, they're cut and fill. Yeah, then we get to this road design with volumes. And they're just doing some road design. So we're going to go through, some of the tools with that. In this tutorial, it's pretty stock and pretty straightforward. There's a lot of tools that have really grown since, and in particular, one is called RoadNet. So we're going to go through all of that and see how that works for us. And again, a lot of that is somewhat geared toward or directed toward the designers, whereas we're going to be given this road design. And so we're going to either have the actual alignment files and the profiles and the cross-sectional depths, what's called the drawing template, or not the drawing template, the roadway template, or we would build them from the actual labeled components. We know station to station, length of a tangent, the radius of a curve, the incoming outgoing grades of a parabolic vertical curve, all of those different things that we can actually build into the editors to recreate what the designers intended. So, so we'll see what those tools are going to do. And then they've talked about this drill hole data. Now, if you do not have the full takeoff package or the geotechnical module, and Val, Ray, and Matt, you guys probably do not. I think if you are just using civil and survey, and there's not a lot of stuff to have to, we're not going to actually go through a lot of effort here, but I want you to be aware of that in this manual so you can sort of read and learn about this on your own. And the only thing it's really going to do, and you can do this separately, in your civil tools, is you've got drill hole locations. And here in this particular site, they've got 3 drill holes. Now you can think of that as a survey point, and it has multiple elevations. Okay, and the elevations down that drill hole that you would get with that data would be the tops and bottoms of particular layers. Like you go down through, topsoil, and then you get some kind of an overburden, and then you get down maybe a shale layer, and then finally you hit bedrock, or you drill, where they drill to refusal. So you can actually take those 3 points multiple times. You make, one set of 3 points with the elevation of the bedrock, and then you can build a surface out of those 3 points. Then you can do another the same 3 points X, Y, but change the elevation to be, say, the top or the bottom of the topsoil. So then how much you have to excavate to hit to the bedrock, so you can govern your, extra excavation amounts. So you can do it in civil. You don't need the trenching, but this is the tutorial steps that you're going to see here in this portion are based on having that data. And then it talks about these volume controls and uh, the cut fill heat maps and that sort of stuff. Then there's this one here for the trench network. and it uses it. And all of these files, by the way, are in your data sets. Okay. So Ryan, you'll be able to do these. We're not going to take class time to do these since not everybody has them. But it lets you step through, putting in this set of pipes, and you'd again build those design surfaces, and then you can actually have it color code the pipes. I don't know if they've got a picture of that or not. Yeah, here. So different pipes. This is based on the amount of depth in the trenching. So you can sort of get a sense of it like that. And it also breaks out um, breaks out the actual materials based on depth zones, that sort of stuff. So there's a lot of nice little finesse tools that are there that you can sort of do your own. And that's really about all you need to take out of this 800 and some page manual, is that little tutorial section, but it's pretty nicely done. And it also documents some of those commands, and you may find them on different locations in in your particular software, a lot of which would be under that SiteNet menu. So it's a nice little resource to have. That's why I've included it for you here, even though they've never rewritten it beyond that 26 version to my awareness. They may have, but I haven't seen one lately. Um, but it's still, even as old as it is, it's not too terribly bad. Okay. So with that said, let's jump into what we have. Let's go ahead and load up Carlson, and I will load up. Well, first of all, let me see. Well, there's no need to show you. This is that standalone takeoff. It's got a different set. The menus are just slightly different. There's no particular need to deal with that right now, but I'll show you some of the different modules and what they have. So let's get started. If you come to the start menu, just make a new drawing for now, and just take the defaults. Although what I would tell you to do in case you want to save what you're doing, wait till it works its little magic here with Windows. There we go. So I'm going to make a new drawing, and I'll start it with let's just use the National CAD standards. So it doesn't matter at all what template you're using. I'm just using that as a example. So we'll go through that, and we'll make our scale, say a 20 scale drawing. I'll make my symbols 1/10 of an inch tall and 1/8 of an inch for my text size. And if I knew if I'm working in state plane, I would set that up to match, whatever my survey data or any of this stuff is going to come in, because you can also underlie your work with aerial images, that sort of stuff. So for now, I'm just going to leave it to none. And now if I were to try to say next at this point, I was going to say missing drawing name. And this is one of the reasons I like to use this startup wizard, because if you see down there in the lower left corner, it says skip startup wizard next time. A lot of people turn that off. They'll check that on so that it skips it and it turns it off. But I like the discipline that it imposes on making sure you tell it where the drawing is going to go. So I'm just going to hit the set button, and I'm going to navigate my way around. Now, right now I'm starting in Carlson projects, and I can choose a list of, here's some of the recent folders I've been in. I see some subfolders here in this subfolders window. These are all the subfolders inside Carlson projects. I've got in this window all of the files that are in that folder wherever I'm sitting. And then this down below is a list of recently used files, regardless of where they are and regardless of which drawing I was in. So I'm going to go over here in my subfolders, and I'm going to find this 2025-04-10 3D machine control class. I made that as a place to do my work. And I put inside that location another folder here called subfolders. And by the way, if you just hit the browse button, it takes you out to the Windows. You may be more familiar with that. Takes you to the Windows file picker. That's perfectly fine. I like Carlson's file open dialog because on a lot of different types of files you look at, you'll get a little preview. You'll get information about point files, things like that. So anyway, just matter of preference. Doesn't matter one way or the other. So I'm going to look in data sets. And I see I've also got a number of subfolders in here. There's one called Getting Started. I'm going to double click there. And then I'm going to go back up here in the file name and I'm just going to call it my first file. Yes, we're all in kindergarten. Isn't it lovely? All right. And then things like this, the project name and number and location, those are just basically going to fill out headings on reports and stuff. They don't really control much. So that's all fine. And we'll say next, and it's going to ask me next for a coordinate file as part of the wizard. Now, for those of you who are familiar with and use Carlson points, they'd be like survey points. You're comfortable with using the coordinate files. You're perfectly able to do everything you need to do without using the first Carlson point, right? You don't have to use those points. Surveyors, on the other hand, can't draw a square without traversing their way around using Kogo points. And that's fine too. That's their comfort zone. Okay. So when this thing first starts up, it suggests that I create a coordinate file of the same name as my drawing file. It doesn't have to be the same name, and it's also placing it in the same location. It also doesn't have to live there. I can, if I choose set and make a new or choose an existing file, then I can import points from these different locations. Right now, I'm just going to leave it like this and say none. I'll say next. So what it's going to do is build that coordinate file, which is currently empty. And like I said, I may never use the first point, in which case that's fine. I've just got an empty CRD file sitting out there. I can either get rid of later or leave it alone. And then whatever I choose to associate with, I can see up here on the top line of my application, it tells me I'm running Carlson Civil 2025 with IntelliCAD 12.1 not for resale license. Then it says CRD is my first file. And then the drawing file name is after that, my first file.dwg. And so it tells me which ones are located with that. If I were to switch, go to the points menu and say set coordinate file, and let's say I choose a different one. Let's choose this exercise 1 coordinates and open that. You see, it has told me up here that I'm using exercise 1 coordinates, but I'm still in this drawing. And now I can even look in here. Under my points menu, list these points, and I see that, well, indeed, I actually do have some coordinate points in that file. All right. So a lot of people are under the mistaken impression that those coordinate files have to always match the drawing file name. They do not, and they can be freely interchanged, and we're not going to be using them probably at all. So you can ignore those if you will. Now, if you either do not step through the wizard, or if you happen to abort the wizard at that point of it asking you about that file, I don't think a coordinate file gets associated with it. There is no way on the points menu, for instance, to say decouple this point file and don't put anything back. I think it's always going to have something associated with it once it's done. And again, no problem. You can also open up an existing file that doesn't have a coordinate file association with it, and it will say CRD file, none, and then it will have your drawing file name. So all that's, the first step through. Now, I'm going to step you through and just show you a couple of things. This toolbar that I have up here on this, it's the third row down all the way to the left, and this is my Carlson menus. So that's also available under settings, Carlson menus. Okay. That lets me switch back and forth to different modules. I'm sure you guys are all familiar with that. Switch to survey, to civil. And so right now I'm in civil because I've got file, edit, view, draw, inquiry, settings, and points. Those first 7 menus are common to all of the Carlson modules. They all have these and they all have the same commands in them. The individual module that you're in will then display different menus to the right of the points menu. So civil has 3D data, surface, SiteNet, and there's where we're going to do a lot of our work from takeoff. Now you look at some of the things it has in here. Defining layer, surface material and subgrade, display, existing design and other. And down here, you've got make existing, make design, and you've got these calculate total volumes and material quantities. Okay, so and some other stuff. That is the sub portion of takeoff that civil has. If I were to switch to the, in this case, there's not a takeoff module. Takeoff is the name of that standalone program. And it's also called a takeoff suite, which includes civil, construction, trenching, maybe CADNet. I'm not sure what all they've included with it, but construction, the construction module is the sort of equivalent to the takeoff module. And you see here, there's a takeoff menu, and there you see these same things: set layer for existing design and other, define layer, material subgrade. But notice it's got a couple of additional tools like a project checklist, drawing cleanup. But now drawing cleanup's also available over here on the file menu. Okay, it just puts it in a convenient place. And then you've got this make existing, make design, and you've got this calculate volumes, material quantities, but you got some, different additional things, cost summaries and graphic reports and, different drawing to 3D PDF. Well, you can do all that kind of stuff, with other tools, just like a file export, standard export, or you can plot to a PDF. So there's just different ways. It's just a matter of putting things all under one sort of collection here, or repeating them if needed. There's also under here an elevate menu, and this would be the equivalent set of tools, or similar to, maybe you have I think you actually got more tools in civil, and it's under the 3D data menu. Okay, that's how you elevate things. All right. The surface menu, there's another way that you can step outside of this takeoff surfacing where you're doing the existing ground, design ground, and that's basically just a push button. And based on what you've told it in your list of layers, it goes out and does it. Here, if you do a triangulate contour, then you have to select the data you're going to model, and you're going to build a specifically named surface, whereas takeoff makes existing and design surfaces of the same name as the drawing file and just uses suffixes on the ends of those names. We'll talk about that when we get to them. So that's going to be some different stuff here. And you've got, pads and pond designs, and I think pond, I didn't see pond there, but anyway, a pond is nothing in the world that different than a pad. It just sticks down in the ground instead of climbs out of it. And then they include, and again, I'm in the takeoff module, but it includes a roads menu, which is a subset of the civil roadway tools, but it basically includes road network, which incorporates all of these different tools: the centerline editor, the profile editor, the template, where you do the actual design the road template down here. All of those are incorporated in this road network tool. We'll see that. And then you've got a little subset of the survey module. Okay, now let's say you got something here that, man, I really wish I had this survey command that, draws a four-sided building, for instance. I don't see it on here. Make sure it's not here, but so if you have the survey module, obviously you can just switch back to the survey module and you'll get that tool and you can switch back to it. You guys are all familiar with that, I imagine. It doesn't matter where you do these particular commands, because once you're done with, you have a resulting drawn something or saved data file something, whatever tool you use to build that, it doesn't matter. At the end of that particular function, you're left with the very same thing. Okay. Annotate tends to be a lot of commonality across the different modules. And then you've got this display, which you can, and again, we're in takeoff. So display, you can limit your display to only those things that are existing, only those things that are designed, and then only those things that are other. So it's either existing or it's designed or it's other. And they can be color coded. They could be a nice little way. If you have the full-fledged construction module, which has the takeoff license capability of it, when you look at these displays and such with those colors, and again, you can do that as well under civil. I'm going to switch back to civil real quick and look at SiteNet. And you see I can display existing, display design, and display other. And that does that very same thing as design, drawing, design. All of these are coming from the options that you get, but you see how that, there's sort of this crossover commonality that we can use those same tools, okay? So we'll stick with, I'm going to go back to civil, go back in here, and here's my elevate tools under 3D data. And this is where you do things like turn a 2D into a 3D by intersecting things on the screen that have elevation, or by reading a surface model. That's what some software calls draping line work on a surface, or by, giving it elevations, giving it a profile design, giving it text labels. You've got this assign contour elevations, multiple in series or from the text of a label, or a group of contours that all might have the same single elevation. So you can do some different assignments here. Now, the one difference between doing this stuff through civil as opposed to doing this stuff through takeoff is going to be right here. Let's go to the settings menu for a minute. And let's load up the Carlson configure tool, third guide down. And let's look at some of these settings as to what they do. So the one I want to look at is this bottom one on the left-hand column called takeoff/SiteNet settings. And this is going to govern the behavior of the commands that come off of those two menus. And for those of us who have civil and not the construction module, which would have the full-fledged takeoff menu, some of these are not going to have any effect. And I'll explain those when we get to it, and I can show you an example. And it's this business up here in the upper right. Now yours, because some of you guys are at a couple of versions back, they may be arranged in a different spot. I think the colors used to be down here in the lower left. Now they've put them up here in the upper right, but this is the big difference, is right here in these colors. You can tell it to automatically update colors, yes or no. And you can tell it to assign colors by target, yes or no. And what that means is this, and you can set any existing entity's color. If you push that button, it lets you choose the color. Design entity's color, you can choose that color, and then other. So anything that's not existing or not design would be colored this gray. And that's what we talked about, those display design, display existing, display other. Okay. And so that lets you choose these. And when we say automatically update and automatically assign by target is once we tell it the list of layers that hold existing entities or design entities, it's going to switch their color to being from whatever they were, which in most cases with CAD files, and just by the nature of the way we've used CAD since it's been around, those have specific colors labeled as by layer. So they will show up with the color that is defined for the layer they live on. This process here is we tell it a list of layers, and it doesn't matter what color those layers are defined to be. And we say, these are all existing. This set of layers are all designed. And so it takes everything on those layers and it changes their colors from by layer to these specific colors here. And then if I were to switch one of the layer names, say from design to existing, it will change it from, in my case, blue to green. Or if I take it out of those two, it will then make it this color here. Now, sometimes people then are a little dismayed because they want to see the colors back to the way they started with them. And the easiest way to do that is to simply select everything in the drawing and change its color from, and it will say varies up in the properties. You just set it back to by layer. Okay. So, but that's really a nice way to sort of visually keep track of what you're working on. Okay. You don't have to go through and isolate and pick and do all that kind of stuff. You've already done that through the list, and then it's going to declare it here. Now, here's the part where it differs between SiteNet and Takeoff, is this guy right here, this assign color by elevation. And you can say, if it has no elevation, even though I've told it it's existing or it's design, and it should be green or blue, but if it has no elevation, it's going to be, whatever color I tell it, in my case, red. And this automatic update colors means once I give that thing an elevation, it's going to switch from being red to being green or blue or even gray if it's to be other. Okay, and it will do that automatically as soon as I run the command on it to change the elevation. Okay, as long as I'm using one of the Carlson commands to set the elevation, like set contours in a group or whatever. If I simply select something and go over to its properties over here in my properties box, and I find if it's a polyline and I set the elevation, that actually won't trigger this automatic update, but there is a menu command under SiteNet that says, let me cancel this for a second. And it says update. Does it? Maybe you just have to do a regen. If you're using Takeoff, then there is an update colors for set elevations. That automatically reacts. I think if you're not using that, if you're using Civil, you've done it in SiteNet, I don't think. One thing that you can do though is to, oh, well, for one thing, no, here's why that doesn't exist for the update by colors is because SiteNet won't do it. It will, again, back to my Takeoff SiteNet settings, this only applies if you're using that Takeoff module. So in the SiteNet module for running Civil, I'm not going to get to take advantage of this red color that tells me I've got something I need to change an elevation of. I just have to sort of keep track of it in other ways, and that's fine too. All right. So that's something that Ryan in particular, if you're not familiar with, and you might want to take advantage of that, and we'll show that in part of our exercises here. You might want to take a look at that as a setting. We've got some other modeling techniques here is to whether we want to extrapolate out to if we've got a perimeter that says is outside of some of our data, do we want to push that surface all the way out to that outer boundary? And it's there so that you can do things like if you only model up to, say, the back of the curb around a surrounding parking lot. Remember I told you about that we don't, in the example that they show us, the little tutorial, they stop there. They don't really worry about tying that into the existing ground. That's a way that will allow you to sort of tie that in to, um, and it basically goes all the way out to wherever you said, this is the end of my work, this is my boundary. And it basically just projects that elevation down to that outline. Okay, if you turn that on. And then you can also, if you have that turned on, you can then use the existing surface, say underneath all that, to extrapolate the design. So it would stop at my design at the edges. We'll talk about this in a minute when we load up a file, different file, and I can show you what those things are. But this means that if I do this, then that means my design surface is going to go up and let's say to the top of say my back of my curb. And instead of going from that point down along a sloped line down or up out to where that boundary is, if I turn on to use the existing surface, so what it does is it goes up to that back of the curb and then it drops essentially straight down or goes straight up to hit the existing ground and then runs that out to hit this design surface. Now, I will tell you that uh, I typically don't do that extrapolation because I'm going to govern my extents based on where I know I've actually modeled my data. And so it would have no effect. So I'm just going to leave it off. All right. The other ones I have here is to use binary triangulation. And that just, there's no real need to use the ASCII format for that file anymore. This next one right here, these next couple of things are whether I want to minimize flat triangles, either for existing and also for design. Now what that, and densified break lines, that's another option here that we need to understand. And we'll talk about what they do here in a minute. But it's probably good to have them on like that. Do I want to necessarily do that for design? Well, if I'm telling it that the things that make up existing are a bunch of contours, the thing that make up design are a bunch of contours, pulling out of contour layers, then you want to turn these on. This minimized flats is always going to be primarily useful for modeling things based on contours, which is the worst way to do it unless you can draw in the break lines down the noses of those contours to make them more accurate. We'll see an example of that and how it might affect our work. So let's see. And then the densified break lines is again going to control how often a triangle corner forms. And again, we'll see some examples and how that might apply. Drawing the triangulation surfaces, this surface object is not really fully finished yet. I think this is Carlson's sort of toe in the water to be able to create this extended thing called a surface object and make it part of the DWG file. They've always kept those files external in these .tin files. And when you want to see them in your drawing, you can draw them as contours. You can draw them in as triangular faces, these 3D faces or just the line work. But and basically what you're doing is you're reading that external file and you're creating the geometry in the drawing file. So it really doesn't matter there. It's not going to automatically draw those things like that unless you tell it to draw the surface, and that's going to be how it draws these things. All right. So again, I don't think that one is quite fully baked yet. It doesn't cause any errors. I've not seen, it doesn't really generate a surface object that I've been able to determine out of that. I think they're just getting ready for when they get that finished. All right. Reducing the triangulation surfaces. Again, if you're putting in a 40,000 acre, a car assembly plant and a bunch of parking lots and stuff, I've seen things, and in fact, I was hired once by the North Anna Public Utilities Commission, the engineering department out of there, when they were expanding the North Anna nuclear power plant in Virginia, they wound up with these surfaces that were so big and so dense they would not fit on the dozers and things that they were trying to use to create it. So we had to do a number of things. We had to split the surface into like 3 different zones, and then we had to reduce the actual triangulation data because the engineers that modeled it had, you know, had that, say, a whole lot of unnecessary triangles. A lot of triangles were side by side, all lying in the same plane, whereas, 15 little sliver triangles could be represented by one triangle and had the exact same data or the exact same surface information. So, but in general, I I leave mine set to none because I don't like to have it uh, go through and decimate or strip out things because I might have some little subtlety that I want to keep in there. So I leave that set to none. Now, the rest of these things underneath it, for those of you who may not be familiar, and we won't spend a huge effort here, but I just want you to see this is the difference in approach between the takeoff way and the CAD way or the civil way is when we do it the takeoff way, where we're only talking about making an existing surface and a design surface. You got 2 surfaces. They stay the same name as the drawing file, but you create these surfaces with these little suffixes. And here's this under the left-hand column, you've got the existing, the right-hand column, you've got the design, and you can see it will take the file name and put OG for original ground. That's before any adjustment. After any subgrades, that's that ZE or the zone extraction. And then after subgrades and topsoil have been stripped and replaced or whatever, it's just called EX for existing. Same thing for design. Before any kind of adjustment, just BS for base surface. After any zone restriction for subgrade zones, it would be called a ZN for zone. And then finally, after any zone and topsoil replacement accountings for those, it will call that as a .FN or a final. And then of course you got an over excavation surfaces and OX. So these are just individual surfaces. It always generates these 6 and the 7th if you have defined the over excavation, but these 6 for sure, it will always do once you make existing and make design. And then you can look at, slices through your site and you can see all 6 of these actually show up. And we'll see those. Okay. If we are not doing the takeoff way and we're doing everything the civil way, we don't have to worry about any of those. And we're just going to keep track of whatever we name the surface itself. We might call it EG for existing grade. We might call it, PROP for proposed grade, anything we want, but they don't use those extensions unless we tell it to do so. All right. And now the potentially confusing thing is that we can still model things the civil way, create these individual files, and then stick it into the takeoff way, declare it as the design surface, excuse me, the design surface definition, and it will still go through and make these as a separate surface file. So it's not a bad approach. You can model it very closely, very accurately, the civil way, stick it in the takeoff way, and use that to generate materials and quantities and subgrades and all of those different things. Right? But those are those primary settings and what they do. The colors, now these part for existing design and other, the green, blue, and gray, those will work in SiteNet. You just will not be able to choose this color by elevation using SiteNet only. That's only available using takeoff or using the construction module. Okay. So let's say okay to that. And I'm going to then show you one other set of settings here that I want you to look at and think about, or maybe two. So I'm going to look at the surface settings, and this upper half have to do with when you're building surfaces, if you're using gridding, if you're making a grid surface instead of a triangulation surface, those are going to govern how that grid gets built, like how far out from each point to look for another point into which quadrants, northeast, southeast, southwest, northwest. What dimensions that you're going to make each of those little grid cells, etc. We're going to do almost everything in triangulation format, so we're not going to worry so much about that. And then the one thing that I want you to make sure it's on, if you have this option, is to track the tin history and include the detailed source data and also track surface data changes. When you do that, that's, and I think Val, you said that you had the Civil 3D background. That's sort of like being able to either, skip over, delete, or restore any particular edits that might have happened to that file through the tin history. If you, got into doing tin edits and all that, this also allows you to do that with the triangulation file manager, that you can control that so you can dial things back without losing those edits that you've made. Otherwise, once you make the edit and resave the file, it's unaware of, what it used to be before. All right. So that's a couple, these bottom ones are the ones that I think are important to have on. Now let's look at the last one I want to show you about is this general settings. And I'm just going to leave this up here. And I want you to, you can choose this to match if you want to. We're not going to go into a lot of detailed explanation here, but I will explain a few of them. This top one right here, I've talked about that startup wizard. If some people check that box when they come in, they don't like to use it. If you ever want to go back to it, here's where you tell it to use it. This is the only place to turn that back on. Okay. The other ones that are important are over here on the right-hand side. And this object linking is whether or not you want, and see, it says link line work with points. So if you've drawn lines based on point numbers of coordinate points in a Carlson coordinate file, and then if you move that point, well, it pulls that line, or at least the vertex of that line work that goes through that point, it pulls it along for the ride. Otherwise, it just leaves it where it was originally drawn. So any changes to those points is going to change the line work. Now it's one directional. If you go and just grip at the line work and move the grips around, it doesn't pull the points with it, but the points will pull the line work. Likewise, labels, center line. If I say do some line work. Maybe it's a property line around a boundary. And I've told it to annotate and label the area and label the bearing and distance along certain lines maybe. And then if that line work changes position, it will recalculate the new bearing and distance and new area, erase the old and redisplay the new based on that link being on when the annotation was done. And this is not a turn it on, do your stuff, do your annotation, and then you can turn it off and it won't change it. It's whatever's in effect whenever the command was run is how that behaves. If you need it to change differently, you would have to just rerun the command with the switch turned a different way. All right. The link line work with center lines is nice because you can make center line edits, and once you save that and go back out of the editor, it will automatically redraw the center line without you having to go to the command that says draw the centerline file and blah, 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 blah. It just automatically does it. Likewise, if you just make a grip edit on the screen to a centerline, it's going to go into the centerline file, the definition file, and actually update that. So if you draw something and you change the radius of a curve or the length of a tangent or even the direction of it, it will go into the centerline file and make those changes just as if you had typed in the new values. Now, this part in the lower right is the sort of important one for our modeling efforts. There are, let me leave that there for you to look at for a second. You can set them to that, and I'm going to get out of this and just draw you a little example on the screen so you can see what we're talking about as this happening, okay? This is called the arc removal reduction methodology, whether we use maximum offset or chord length, and then the values that we're going to use, okay? So you can set those. Now, I think out of the box, Carlson used to have this max offset set to something ridiculously small, like 0.00001. And that's all fine, but it made for too many triangles. These are all good numbers by rule of thumb, and I'll tell you why. So it's 0.02, so I'm 2/100ths of a foot. That's hardly measurable, especially if I'm pouring concrete. And my chord length, I've got a 6-inch chord length that I want to use as a potential maybe. In fact, I might even change mine down to, let's use a 3-inch. So here's what those two things mean. I'm going to go ahead and get out of that. Save those. I'm going to draw a 2D polyline, and I'm going to put this on, say, a layer here, C road center line. There we go. And I'm going to go, okay. I'm going to go here, and I'm going to go for a distance of, say, 100 feet. And we'll go toward the cursor. Now let me zoom way out. So there we go. And that's good. I'll type Q to quit. So I'm back now here, and I'm going to type an arc, A for arc. And I'm just going to say let's see, the radius. Let's just do the endpoint out here. Say like so. And then I'm going to go back to line. And we'll call it, say, another 100 feet. And that should be good enough. I'll just enter to conclude the command. Now, I've got this line pattern is way too hard. I'm going to set my LT scale back down to 1. Okay. So now, when you select this guy, it's a 2D polyline. You see grips on the endpoints of each segment. There's a tangent segment, then here's the arc, and then an outgoing tangent segment. You see also some halfway points. Those are what 2D polylines have, these midpoint arcs. They let you hover the mouse and you can do, you can say, convert that to an arc and, do different things with it. All right. But the basic grips are the endpoints of each of these pieces. And again, you can, by the way, hover that one and convert it back to a line. So if I were to say, try to model this as say the edge of my pavement, all right, in a parking lot or a shopping center. And I had another thing, and let's just we'll just set that to be all right, so this is going to represent a brake line. All right, I look at that, and it's also got vertices at each point. So if I were to model this as part of my surface information, I'm going to wind up with triangles that are going to form like this. And now you can imagine that there are, this triangle here, for instance, right in here, it also has an edge that goes across here, but the triangles are only going to be allowed to form between where it finds those vertex points. A couple of ways we can handle that is what's called densification. And just show you where it is on the menu. We won't worry about this. You don't have to try to remember it, but it's under polyline utilities, where if we say we want to densify the polyline vertices, even though that's a straight line, it's going to drop additional vertex points all along its length a certain distance apart. And that's where you also saw under your settings down here in the takeoff site net settings, we said densify brake lines every 10 feet. So it's going to automatically do it. You can also see that when you run the standard civil, triangulate, and contour command, it has that option here as well, densify the brake lines. Now, what happens when you do that using those processes to build the surface? It's going to do that, and it's going to put those extra vertex points all along those features, and therefore allowing those extra triangles to form along those edges. As if those points were in that feature. Now you can imagine if they did this for the entire huge site, we're going to get all these extra vertex points, all these extra vertices on all of this data, and it's going to make our drawing file really big. So what happens is when we turn that switch on in those commands to build a surface, it only does it in memory long enough to create the triangles, and then it throws them away. It no longer uses them. So it's a little bit more efficient. Now, what happens when we need to give this and this a certain elevation? So right now they're 2D, okay? If they have actually, different elevations, which they will in the real world. This is, where we turn into our parking lot, and it's wherever the curb elevation. This is where that, the concrete curb runs out and goes around the corner. So they all have differing elevations, as does, say, out here. Maybe this is back inside. It's my edge of my, this might be all grass out here in between. Maybe this is the edge of my pavement. So it's going to have different elevations. Now, the triangles that you see here would also form this same way. And if I did not densify, these would be the triangles that it would use, and that'd be fine, except for right in here for this arc piece. And what's happening there is, and I'm going to change this to show you a couple of examples. It would do something like this. And let me turn off my endpoint, just go to nearest, all right? Well, let's go to, apparently it didn't believe me when I said turn it off. Okay. So what it's doing is the CAD system, or any CAD, doesn't matter if you're using AutoCAD, IntelliCAD, Bentley, ArchiCAD, anything. When we give that red edge that you saw, the original edge, when we give that elevation, we give it differing elevation. It's going to set an elevation at this point, and it sets an elevation at this point, and it might even have a change of elevation somewhere along the line, but we don't know. So, but in other words, it still has to take this original red edge, which is a circular curve. Okay, it is a true portion of an arc. It's a true arc. And then when we let me turn these. Turned. There we go. All right, so then when we let's see, go back to then what happens is when it converts, or when it makes this into a three-dimensional entity, this has an elevation here and it gets an elevation here. And if it's a differing elevation, now here's what I want you to picture in your mind. You're standing there on the ground looking straight down on that piece of an arc. It is a true arc. It has a radius that's equal all the way around it. Now, let's say you pick this whole thing up and you set it down at an elevation of 100 at this corner. But then you walked up here to this corner and you had a buddy hold this back corner at 100, and you go up here to this corner, you pick it up and set it at 105. Well, it still looks exactly like an arc as you're looking straight down on it. But what is that figure? Because now this corner's up in the air. And so if you were to look perpendicularly down on that feature, you'd have to be sitting up here and looking so sort of down at an angle to see that in plan view. And it's no longer an arc. It has been stretched out in that particular plane. It's been elongated. So it can't contain the geometry of it as a circle anymore. So the only option it has to do is to mimic the look of that circle in plan view by substituting along its length a series of little chords, which is what you see on the green there. So the setting back here under Carlson Configure General, over here, this max offset and chord length, whichever method you choose to have the software use, doesn't matter. It's just going to do whichever one you want. It's going to honor these values. I've got a max offset of 0.02 and a chord length of 0.25. What that means is when it takes this red, what used to be a circle, and you give it elevation, it has to create those little segments here, these green segments that you see. If I do this according to my settings, I'm saying allow the maximum offset from that curve to be 0.02. And that would be this. God, I'm not in AutoCAD, so. I would say the maximum amount I want these chords to be is that 0.02. It would be this little figure right there. Okay. So it goes all along its length and it creates those little distances and decides where to put that little chord segment. And it goes from the last point it did through the end point of that 0.02, and then it goes out to where it hits the original arc location again and sets it down there. And it computes the elevation of this green piece based on how far away it is from um, this endpoint here to that endpoint, wherever it had the last elevation. It interpolates along there wherever it hits here, it interpolates what that elevation should be at that point and sets the elevation of this green segment accordingly, and it puts it at that distance away as that maximum offset. Now, again, I say 0.02 because you can't really see that very effectively. It's not going to be that big a problem to build something based on that as the distance. Likewise, if you wanted to use instead the chord length of, let's say you're just going to put 3-inch segments all along that curve, then it would do so accordingly. Now, I use the offset method. It just happens to be my preference. Uh, you can think about however you want to do it best approach. Now, what happens is whatever you do, and let's say if we had the old default version that Carlson's programmers left it in when you install the software, it's something like 0.0001. That number is very, very tiny, and so it makes a slew of these little green segments. You go until you get around there. Now, here's what to remember, and here's why you need to understand the effect of that. What happens then is that you get a bunch of triangles because every single point along these features gets used, to make a triangle. And I'm just going to do partial triangles here. Oops. I'll turn that off for a second. So there we go. So everywhere it made all those little itty bitty zip, 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 zips, it's going to set a point here and a point here, and each one of those, and it makes all of these little teeny tiny skinny triangles. You can wind up with literally thousands of sliver triangles around an arc because every single point that it finds in the data that you use to model the surface is going to become the corner of a triangle. So set that number too small, you get a huge number of triangles, and then you get surfaces that are hard to work with. They can bog down your dozers if you have that same problem like we had in that North Anna power plant. So that's a reason for not setting those numbers too small. But likewise, you don't want to set them too big either, because you could wind up with something like this, which I've seen happen before, where somebody's just got, in fact, let me move that to the midpoint. Yeah. So I've seen this before where somebody has not had them tight enough, and they wind up going out there and trying to build it. Well, this will model, this will compute volumes and do all that kind of stuff, and everybody's happy with it, except when the poor sap like you guys who are driving the dozers have to go out there and build this curb, you're going to build a curb that looks like that green line unless you've densified that, or if you've, you know better when you're out there on the ground, you catch it. But the point is, make that number too big and you get too few ways to model this. And I've seen engineers do this. They don't know that this is going on, and they just blithely go about their business. So if they look at something, say drawing a line from out here in the street and crossing up here, they should be hitting the back of the curb at a certain location, and they're a foot or 2 feet away from it because that surface was built according to that. They never see the triangles. All they see are the resulting drawn contours, and they think, oh, everything's pretty, everything looks fine, I'm going to leave it at that. Okay, so that's what that number means. And that's all we're going to do with surfaces. And we're going to go ahead and finally take our mid-morning break, which is a little bit past our mid-morning point, like 20 minutes past. But let's go ahead and we'll go ahead and get you your close to your full 15 minutes. Let's come back at 5 minutes after the hour. First of all, before we run, let me ask, does anybody have any questions at this point? Okay, we haven't really jumped into much other than settings.
Ken,
Everybody
I
good?
might have a question, and I don't know if you'll cover this at all. I've been doing some pretty complex modeling, and I
Uh-huh.
have a problem with my triangles jumping over my break lines to get to like a closer
Uh-huh.
vert.
So uh we won't really necessarily, that's not really necessarily something to cover. There's a reason for that though, is that for whatever reason, that particular brake line is not behaving like a brake line.
Yeah,
Uh,
and I don't know if it's like the computer not being able to process it, not
no, it's not that. I will tell you, I've also had that problem in other software, not with Carlson. I've always had Carlson's always honored the brake line issue. Um, the only thing I would recommend that you do is go back and make sure you look at the elevations on those brake lines. What's been my experience is when you get things like that happen that you think should not, if you, like I always do this, I pick these drawings up and I spin them around in 3D. I do this. And if you do that, take it out of plan view. And if you see like one of those brake lines might go from there, it is straight drop down to zero. So even though you think it's,
yeah, it's not doing that. It's just I'll have to maybe just send you an example sometime the
uh,
next time it does it, because I'll end up just going in there and drawing a 3D line to kind of connect it, and make the triangles,
yeah,
go
that's
where
what
I want.
I mean, brake lines have to be 3D brake lines or
Yep.
2D, but they have to have elevation.
Yeah.
So as long as they do, now I've actually had some things that automatically track that stuff, like some other software, say on the Bentley side, that will temporarily lose track of those brake lines and what they call soft brake lines. And really the only way around that is to turn it off from being a brake line and then turn it back on, and then it sort of wakes itself up. So I know that's not a solution, but generally it's not an issue. And you can always take a look at it when you look, if you obviously you've seen it because you've seen the
Hmm.
you've seen where those go. So um but I would keep a track on of that. And if you do get that, be sure and send me that, send me.
Yeah, because I've been having
Oh,
it happen. I've been used to using like Autodesk in the past, and I've never had that issue before. And I've been using IntelliCAD now for about like a year, and
yeah,
it's just on like the complex models that I'm doing, where I
right.
might have like a high vertical face on it too. Not
Well,
not a zero elevation, just maybe like 30 feet or something like that.
yeah, but that's okay as long as you make sure that you're not trying to model an overhang, because sometimes
Yeah,
that,
yeah. I might have like a hundredth of an offset on it.
which should be fine as long as it's
Yeah,
not, well, and as long as it does not overhang. If it leans back,
yeah. It's leaning back. It's just jumping over the brake line to get to the closer node.
Yeah, I mean, I understand exactly what you're saying. I've never
Yeah.
happened with Carlson. So what I'd like you to do is next time it does happen, or if you can go back and find an old file where it did, send me the data. Just send me the whole drawing file and the 10 file, everything you've got, and I'll be
Yeah.
glad
Yeah.
to look at it. And if I can't figure it out and it's still happening, I can, I'll elevate it up to Carlson tech support, which you can also do on your own, by the way, but
Uh-huh.
in case you haven't. But
Yeah, it's just a little frustrating. I gotta go back there and like modify and add some 3D lines because I'll see the triangles jump over top of it, and you'll see the 3D polyline. It'll be like above the surface, kind of when you're looking at it.
yeah, well,
Next time it happens, I'll just email it to you.
yeah, do that, and I'll be glad to. And we can also do just like we're doing here. We just do a little Zoom connection, take a look at things and see, and be glad. And that, by the way, is part of what you guys get when you become an MSoft training client. You get access to my wonderful pickled brain. Uh, so, I've seen this from a practitioner standpoint. And again, like I said, I'm not a software salesman. I don't do that. I'm a practitioner. So hopefully, you know, take advantage of that resource. Now, we wound up pushing up here to almost 11 o'clock. So we're going to go to 11:15 on your break. So now you get 2 extra minutes. Any other questions on what we've gone over so far? I think you guys probably understand this well enough. All right. So I'm going to suspend the recording. I have paused it and then gone through a whole afternoon session and missed it. And there's no way to recover it. But anyway, so if you see me doing that, forgetting to turn it back on, let me know. All right. So that gave us an idea of what some of those settings can do and what impact they may have on what we're doing some work. Here's a couple of other things I want to illustrate. Let me see what would be the best. I'm just, instead of continuing on, I'm going to close this file. No need to save it. And I'm going to have you open a file out of your data set. And let's look in our data sets folder, and then inside of that in the getting started folder. Okay. And I want you to scroll down, and it's probably the last, it's the next to the last drawing file called sample from T3 Global. Go ahead and open that file up and let it load. And we're going to use this to illustrate a couple of points here. And this is purely an existing condition map. This is actually, and you guys at Plum Contracting will be familiar with this here in just a minute. You'll see where it happens to be. So I'm going to go to my settings and look at my drawing setup. Well, I thought I was going to. I must have missed the click. I don't see it. All right, so there's that one that came up. There we go. Finally got it. All right, so I'm going to set this to, say a 20 scale should be fine. I'm going to set my LT scale back to 1 just for yucks. And I'm going to set my projection to a predefined user-defined projection. And I'm going to choose the defined projection as the one. And if you don't have it showing up, you can add a predefined and scroll down and find your particular area. You can look in these different places in the world. We just use USA and scroll down and find. And in our case, I'm looking at USA NAD 83, the national or the North American datum as for horizontal of the 1983 adjustment with the 1986 readjustment for Pennsylvania South. That's the 2011. I want the I don't have the 86. So let me add that. So I'll go to add predefined. I'm going to search for Pennsylvania, so net 8386, PA South. That's the one I want. All right, so that'll be the one that I use. The pre-2025, maybe even pre-2024 versions, when you hit this define projection, that list is pre-populated for you. Or actually it's up here. When you pull this down, you can choose it. Now you can only choose either none or a predefined, or you can use NAD 27 or Universal Transverse Mercator. But anyway, so I'm going to set this to PA South, and you'll see why here in just a minute as we do it. All right, so I've got that, and I look at this, and there's a lot of stuff about this data. You can show you if I select everything here and look at my 3D viewer, my view 3D view drawing viewer, it's going to pop all my data up, and I can see, there's all kinds of data in here. It's, I've got points, I've got these white lines. I also see the contour lines. So we're going to take a look at using things from different sources as to how we do it. To give you a little bit sense of the history of this, all of these white lines, in fact, the entire file was compiled from aerial photogrammetry. Okay, and they used the white lines and these pink dots you see. They're just CAD points. They're not Carlson points. And that's enough information that they use to generate the drawn contours that you see out here in our set of data that's elevated. And you can also see, if I turn off this switch, ignore zero, they've got a bunch of things that were kept down here at zero, just the drawn planimetrics, okay? Everything else had been elevated. That's what we would use to model the site the most accurately. So what we'll do is to take a look at a couple of different approaches here. So I want to freeze off these white lines and some of those pink dots down there. So I'm going to go up to my view menu, and I'm going to choose freeze layer by pick. And I'm going to come here and just pick on one of these little white lines. So that whole layer is now frozen. And I'm going to come down here and try to see. You probably can't see it on the screen, but you see there's some little pink dots, and I'll pick one of those, and they're now shown off. So if I now go back and look at this in 3D, in my 3D viewer, I can see those white lines and those pink dots are gone out of my visibility. They're frozen. All right. So normally we would sometimes get a file like this. Maybe it's a PDF, and we've gone through and we've set the elevations on all of our contour lines to their proper elevations. Now they happen to be already done here. And then we would turn around and build this surface. We would build an existing surface from this particular set of data. Maybe all we had were the contours, so that we'd have to build a surface from that. So let's do that. We'll just use our civil tools at this point. So make sure you're in the civil module, and you've got to the right of the points menu is the 3D data menu. And I'm going to go to the surface menu next to that, and I'm going to say triangulate and contour. And I've got, 4 tabs. Is everybody familiar with this tool? Are you comfortable with that? Or do you want me to go over a couple of things with it? Like, I won't go into any detail necessarily, but a couple of things that we want to always focus on. Usually the first time I run this command, I always check my selection tab to make sure I have not placed any filters on it the last time I ran it, because these stick between sessions. and between projects. So I want to make sure I'm not filtering anything if I don't intend to. I'm going to go to the contour tab and make sure that I uncheck to draw the contours, because it will automatically draw the contours once it computes the surface. And you can turn that on and off if you want to see some differences. In fact, I'm going to turn it on for right now. And I'm going to set the contour interval as 2 and the index interval at 10. And I'm going to draw my index contours. Okay. I'm going to have no smoothing. And I'm going to go over to triangulate. Now, I want to write the triangulation file. That's the one thing I want to do. So I'm going to hit the select button and I'm going to save this file. I'm going to come up here and call it T3-EG-CTRS. So I'm making an existing grade on this T3 surface, on this T3 data from contours. Okay, I'll say save. And I'm going to say, I'm going to uncheck all of these things because I can see all of these different lines in my viewer. I don't have to draw them into my drawing if I don't want to. I can always see those in my viewer. I can draw them in later if I need to, but I'm not going to. I'm going to uncheck use the inclusion exclusion areas because I have not drawn a boundary around it. It would, therefore generate surface data over here in this little inset area, except for this little guy right here that says shrink wrap perimeter reduction. And that means when this command runs, it's going to run another command that we have. We used to have to do this separately. It's going to shrink wrap this data. It's going to draw a bounding edge around all this data. And then the amount of reduction of the perimeter. And this is basically, if you've used other software, Val, in terms of Civil 3D, this would be like setting the exterior triangle maximum length. And you could also set that down here in this field over here, this exterior maximum edge length. You could sort of control it that way. But if you use it from this shrink wrap, you've got a choice to say none, in which case it draws from this outermost point all the way up here to this outermost point. And so it would include this region. So you would get those long, skinny triangles in there. If you set a high reduction, it goes around here and you'll see it even jump in between each contour line a little bit. And it might make it a little too jagged. So, I'm going to set this to just a medium reduction. And then you could go to your setup tab. And if you wanted to draw that perimeter, you could. I'll go ahead and draw it as a 2D. And you can see in the results of that as what's going on. You don't have to draw that. It just does it in memory, but that also lets you check to make sure everything's kosher. And let's uncheck the 0 elevations for a minute and uncheck our densify break line. So nothing else is checked down here. I've just got to write the file. I'm using a shrink wrap reduction of medium. I did choose the setup button and say draw it. And erase previous contour entities. I'm going to leave those as off for right now. Well, yeah, let's just go ahead and say all contour entities, because the next time we build the file, if we don't erase the bad ones that we had, it's going to use them in the data that we select. So we'll go ahead and turn that off. We can also, just make sure we erase, and we can erase by layer and that kind of stuff. So on my contour tab, I drew the contours every 2 feet. And on the labels tab, I'm not going to label anything. I don't need to track down any text for it right now. All right, so I'm good to go. I'll say okay. And it says at the command line, select entities. Now get familiar with and sort of in the habit of anytime it's asking you to select entities, read the line above it. Because depending on different settings, if I had said I did want to use inclusion, exclusion areas, it comes up and says select entities. But the line above it says select any inclusion perimeter polylines. And then you finish that selection and it goes to the next one and it comes back and says select entities again, but it's asking you to select any exclusion entities. You finish that selection set and then it says select points and break lines to triangulate. That's when you would select all this information. Now, what used to happen to me the first time I was running this command, I saw select entities and I just went, oh boy, and I did a window around everything, but it was trying to find the inclusion polyline. So get in the habit of reading the line above as to what you're actually selecting. So now, since I'm not using that function, it is asking me for the data. So I'm going to take this data, I'm just going to draw a window around it, and there it's going to be something really goofy because, and you'll see it show up here. And you see all these different contouring elevation. You see it's going through those numbers. Now look what happens, and it's taking a good bit of time because some of you guys might have already picked up on why. I hope it didn't bog it down here. But basically, I'll tell you the reason why it is because I had unchecked that little box that said ignore zero elevations. So it's trying to build a surface every time it sees those zero elevation locations. It's trying to draw those contours for all those elevations. It did go ahead and write the file. I see I'm not making much headway here, so I want to, I don't know if I can escape it at this point. Yeah, I can. Okay. Maybe. Give it another couple of seconds here, and then I'll kill it and start it back. Go ahead and kill the darn thing. Sorry, I hung it up on too much crap. I'd have to do it. May still be working, but I'm going to just go ahead and end it. And I'll start it back up. So now, once this settles down on this side, by drawing back up, please, this information, make sure I get one of these. Points there, make sure I don't have any left. Okay, good. All right, so now what had happened when I did that with that zero elevation, if I view that surface, there's my T3 EG. Come on. Oh, see what it's doing at the bottom of my command line? It says found and eliminated a vertical edge of length 2. All right. Give it just a little bit longer. So if it stays on forever, I don't. All right, there we go. All right. So what wound up happening with this? If I can get it, boy, there's a lot of crap in there. Oh, it's still finding and eliminating. Sorry, bear with me one more time. I apologize. I won't do that again. So, so what wound up happening, is that it tried to make the surface, including those things down at 0, and they were obviously, that's not the right way of doing it. So, but sometimes you are so close to being down at 0 that you can get away with it, and it'll make your surface information bad. So we'll just get rid of that switch and we'll do this over again. All right, so what I'll do, I'll do that. And I'm going to go back now this time. I'm going to rerun triangulate and contour. Now everything should be as I set it. There's my file, but this time I will ignore 0 so we can take that out. My select, I'm going to choose that same file name. Yes, it's okay to replace it. Make sure that's still good, that's good, that's good, and say go. And we grab all our data. And there it is, and it drew the contours. It also drew this outside line, which was this boundary topo. Let me change that layer so you can see the boundary 10, rather, not boundary topo. I'll make it red, and I'll give it some weight so it'll show up here. And then I'll make sure that I turn on the line weight view down there in my settings. So that is, you see, when I told it to shrink wrap and I gave it a medium reduction, you see how it got here and it jumped in a couple of places. So that's the actual extents of the surface that got built. And if I look at that surface, I can see a couple of things. It's either looking like that, and I'm just coloring that in, or I'm going to go over here and turn off to display the contours. And so I've got a bunch of things in, and here's the issue I wanted to point out, because I'd use those contours only. Can you see the edges of that street there, the edges of the road here, these little stair-steppy looking things? Because that's where a triangle, or not a triangle, but a contour that we used for the data. Let's change that to 1/5. You see, when it, excuse me, when it tried to triangulate this data, it read along the original contour line, which followed here, and it went all the way up to here and then back around. But it built this triangle across because it got up here, and the closest thing it could find was itself across this other gap, because there was nothing in between to keep it from looking across. There was no break line from nose of the contour to nose of the contour. This one managed to do okay, but a lot of these did not. Okay, so we get that as a problem. So the way to fix that would be to go back out to our drawing file, and we would draw in those break lines. Now, we obviously have all of the break lines from the photogrammetry, so we're not going to go through that exercise. But if you ever needed to, on the file that you get, you could just lay in a break line along those nose features, and you can either snap, draw 3D and snap to the noses, or you can draw it as a 2D, and then you can give that 2D elevation based on screen entities, and everywhere it crosses one of those drawn contours, it would read the elevation and set it up accordingly. Okay, so you would have the same effect. Now that I'm in the surface viewer, I can do something like this, add a break line. I'd say add from here to here, and then add from here to here. So you see what I'm doing is whoops, that's too far away here. Let's go from here here to here. Sorry, let me turn the triangles on. Now let's go from I was trying to cross something in there. Let's go from oh, it's not. There we go. Now from here to here. So you could see, you could spend your life trying to track all these down and draw those things there. Now, I wouldn't normally do it using this editor, which a lot of people do. A lot of people like to edit the surface once it builds by doing things like this, eliminating points and setting things up accordingly. So, and then once you make those edits here, you could save it to the file or not. So I'm going to say no. But what you would do then is normally you would draw the lines in, and I like to draw them in as 2D polylines because it's easier and quicker to draw. And then I would go to my 3D data menu and set, let's see, I'll do a 2D to 3D polyline by screen entities. And so I'd pick that polyline and pick the contours that cross it and let it read it. And here's what this looks like in it right in here is a good example. This white line, that's my resulting contour because it formed that flat triangle. Okay, see that? The original contour was this green line. Now it followed it most of the way around, except here it did not. Here it did not because it decided to build that triangle edge first, and it built this one before it said, it just, and there may also be, a triangle edge up in here. That one's correct, but this one is incorrect because the elevation right here, according to my contour line, is 1308. And that's what this one is, 1308. This one is 1307. So really this should be about 1307 and a half instead of 1308. So you see that idea. So
Hey, Ken,
yes.
quick question for you. How did you, I actually had to restart my CAD twice because it got bogged down both times.
Same as mine, yep.
What setting did you change so you can actually make a triangulation file?
When I ran it the second time out here, I just unchecked this, or I checked back on ignore zero.
Okay.
So otherwise it's trying to read that zero elevation because, there are zero elevation lines down here. It's trying to form triangles down to those things as well. So
Okay,
that's what
get
you
it.
want to take away. Is
All right,
that all right?
Thank
Now
you.
yeah, you're welcome. That's a setting that some of the salesman type trainers, they say, always turn that on. Well, that works unless you're working down in Savannah, Georgia, and you're right on the coast, you're down in low country, and you can actually have zero elevation entities down there that you want to consider. So you just have to be aware. In almost all cases, we're able to leave that switch set to ignore zeros. And that's what we want to do because we keep things drawn down at zero that are really going to go into later if we're making a set of construction plans, for instance. You remember the idea about that arc that we drew, and if you turn that into a 3D entity, it separates it out in those little segmented pieces. But what you want to show on your design plans might be the actual arc, so you can label the radius and it's a true arc. Otherwise, if you don't, and if you don't keep those originals down at zero, then when you try to measure the radius of that arc, there's no arc for it to find to label a radius. So that's why we do that separately as zeros. And it's also one of the things you do, like if you're doing like a road center line, which normally goes up and down based on its profile. So it would have a resulting 3D polyline that follows that information, but we want to show it as a center line type line style. And the patterned line styles, AutoCAD cannot do 3D line work with pattern line styles. Everything turns into a continuous line. Other software can, but AutoCAD and IntelliCAD, because of that, because they are an AutoCAD work-alike, they can't do that. So we keep those at 2D so that we can model them with line styles and we can measure true arc information, that sort of thing. Okay, so a couple of things to show you, to point out a couple of things. This red line, that was my shrink wrap, and that was with a medium reduction. If I run this command again, I'm going to repeat my TRI command, which is triangulate contour. Now I've got this erase previous entities set to be all contour entities. So that's set up. I'm going to pull this medium down and change it to none just to show you what happens. So I'm going to say, okay, it's okay to overwrite the original. I'll grab everything. And now watch the resulting. Did I not have? Oh, when I said none, it chose not, the setup went away, so it didn't draw it. But if I were to draw that just with my draw shrink wrap entity, cross gaps, just 2D. That's what it would look like. And so you would get surface information in all of these, and you see it right here with the contours, and that's not really there. So you could do a number of things about that. And you just normally you would take that, oops, not erase, triangulate. So if I changed it from none to a low reduction, and that was that erase previous, you saw how everything went away. And now, so the difference here is you see it doesn't go all the way in up to here and up to here. So you could adjust that accordingly. You might want to pull this out. Now, here's what I normally do is when I run this and get my polyline, if I need this information, for instance, I'll just come up here and just, manipulate this polyline here, either by grip editing, or I might, go through and choose to erase, remove polyline vertex. I'll choose this guy. I'll get rid of that little inset, a couple in there. That would be okay. And then maybe get rid of a couple of these till it winds itself back up. So I can sort of reshape that. And then when I go back to, if I were to do this, I could say, if I turned this guy on to use the inclusion area, then when I run it and it prompts me for it, I would pick that modified polyline around there as long as it's closed, and that would be where it eliminates or cuts off the surface. You could do, anything like this, and these can be, arcs or what have you. All right. So anyway, what we've done here is, and I'll go ahead and just get rid of that. So we've drawn, and again, you see, we still have this problem with these contours flattening out those surfaces. Now, here's another thing we can do. We can either draw in the polylines in which case, if I were to draw a 2D polyline, oh, I'm going to turn my options back on. And I'm going to put this on a layer called 3D-BKLN, 3D break line. And I'm going to set that color to be just by layer. All right, now I may or may not have this layer name in my list of layers. In fact, if I were to select it, I don't see it in there. It would show up between the 0 and the B. But if I just type a layer, it's going to make it for me. Okay, that's another nice thing about Carlson commands. All right, so I'm going to say, okay. Now I'm going to come here and I'm going to say, I'm going to start at that endpoint. Where's my, oh, that's why. Endpoint, midpoint, center, extension. All right. So I may, let's start at this endpoint and I'm going to go down here a ways and go to, say, that endpoint. Now, I'm going to go to my layers and I'm going to change that 3D break line default width. Let's set its color to be magenta. And why it had that set from before, but anyway. All right, and I'm going to erase my contours. So I'm going to get one of those and one of these red ones. So now I've taken that out and I've got this long line, this long polyline. So let's see, I'm going to isolate. I'm going to get rid of those blue things out of my view. I'm going to isolate that and that and that. So now all I've got is my line and the polyline. Notice I missed a couple of nose points. So I can add some vertices in here. So if I take that vertex and I'm come up here and grab this middle and add a vertex, and I'm just going to snap there, and I can do, keep doing that as I need. And I don't have to snap exact, but you get the idea. And I could have drawn it by snapping to those as I went along. So there's a number of tools you can do, and to keep from having to grab the midpoint and add a vertex each time with the grip edit, I can also, from my edit polyline utilities, edit polyline, I'm going to add a polyline vertex. So if I select the polyline, it shows me where the vertices are. It says pick a point to add. So I'm going to go that one, that one, that one, that one. And let's see, I think I already got that one. Okay, so that should be sufficient. I now have that going through all of my little nose-shaped contour areas. Okay, so now, but it has 0 elevation still. So how do I make that into a break line? The break line, that has to have an elevation. So I'm going to go to my 3D data, 2D to 3D by screen entities. I'm going to again ignore 0, and I can give a little gap tolerance if I want. I can extrapolate any ends. I happen to snap right on the ends of things, so that won't have any effect. You either keep the existing or not. You can set a layer name for the converteds or not. I'm not going to keep them, just use what it is. And I'm going to say, okay. And it says to select the polylines to convert. Well, that's that one. Okay, and that's the only one. Now select any 3D faces, lines, and polylines. Well, I can just make sure I get them. I can either type all, so it ignores the ones it doesn't. It now has elevated it. And you can see when I zoom this up, see it's laid that right in along those elevations. Okay, and by the way, if you want to do that kind of look-see without having to load up the viewer, all I'm doing, if you're not familiar with it, is I'm holding the shift key down, and while I keep it held, I'm pressing and holding the wheel on the mouse, and that lets me do that. Okay, and then I go back and either hit the cube or I can type a command called plan and follow the prompts and all that. All right, so now I'm going to restore instead of when I had isolated the layers. So I'm going to now restore the layers. So those all come back, and I'm going to repeat that triangulate and contour command, leaving everything exactly like it was. Okay, to overwrite, and then I'm just gonna type the word ALL, hit enter, enter to finish. There it is. There it is there. And now let's look at that surface in the 3D viewer. And you can see right in there, you see how those contours behave themselves, and where I didn't have them, you see how all those flats are still there. Okay, so that's one thing that you can do. And unfortunately, in a case like this, and let's erase by layer again. I'll just leave what was there. In a case like this, you'd have all of these to do. You had all of these in the center to do, all of these over here to do, all of these on this back edge to do. Everywhere along the lines, you'd have problems. So what we would do, and I'm going to select that 3D polyline now and just erase it. So there's another switch. I can actually erase this too, because it will rebuild it. So if I go back and triangulate that, notice in my triangulation tab, right down here at the bottom, there is a place that says adjustments for source data of contours. And that's what you need to be aware of when you're doing these, and you want to minimize those flat triangles. And that's really the only time that you would do that, is that if you're taking your data from contours, you want to minimize those. Now, it's not perfect. So we'll say, okay, and we'll show you the difference. So we're going to grab all our data here again. And we'll go back and look at this resulting surface now. Sorry, let me turn off. No, let's leave them on. I guess we can see. So you can see here see how it got rid of some of those. Some of these over here didn't quite make it. So, but it's a vast improvement over what we're doing. Now I can look at this, and because I'm familiar with the site, you see this up here? This is, oh, sorry, let me go back to plan view. This is an area that all along this face, that's a edge of a loading dock. And, it only has contours out here defined, and then it sort of chopped them out of my data. So I've got all this information in here that sort of made this little ski ramp kind of thing. I would need to probably add that break line back into my original data set. And that is, let's go back and erase by layer. I'm going to add one more. I'm going to get this boundary. And that's right in here, you see, because that contour ends, and this is that retaining wall. Now, they've only drawn that retaining wall as a 0 elevation 2D polyline. And they just trimmed off the contours at the top. They trimmed them off down here at the bottom at the face and left it as such. Okay, so let's now go back to turn on my layers. Now I've pulled all this stuff from the view menu out of this here, but that's also on my Carlson layers toolbar. And so I'm going to just do it that, and I'm going to say on and thaw all layers from there. But that's where you can isolate, restore, freeze by pick, freeze by selected layers. So now I've got these, and I know that I had some of these individual points that you see down here and these white lines. That's really all that we needed to build that surface. So let's isolate those two layers, and we will choose the isolate layers button right here, or the view menu, isolate layers. I'm going to choose that. I'm going to pick one of those white lines, and I'm going to throw in here and find one of those. Yeah, it found it. Okay. And so now I've got, and you can see those points are showing up in the break lines. And if I look at that in my 3D object viewer, as opposed to the surface viewer, then you can see that's the data I need. So let's build that. And we'll do a triangulation and contour. And this time I'm going to change the file name. Instead of T3EG-CTRS, I'm going to call it T3EG-BKLN-PTS, so break lines and points. Okay, I'll say okay. Select the data, everything that it can see. There it is. Now, I do get a couple of little things here, and these are coming in. These are error conditions, and I can have 3 error conditions: crossing break lines, vertical edges, and T-intersections. And so it shows me, or here's a crossing break line that has 3/10 of a foot vertical difference. And I can zoom to it and zoom in. Let's see. All right, so it's all around this head wall. Now, that's what all 3 of these are. I've got some vertical sidewalk edges. Normally, what you would do is, if you looked at this, now I've zoomed in here, I've got one, I'm going to change its color to be red, and let's give it a little bit of a weight so you can see it. And then I'm going to take this one and make it green and give it a little bit of weight. So that represents a head wall. Now, if I look at this area here, I'm going to spin it up. You see what? So one of them, the red one, is supposed to be the top of the head wall, and the green is supposed to be the base. And so you see, and they cross each other, and they got a little spot, a problem. Now, since we contracted a company to go out and create this information, we would not necessarily make this change ourselves, okay, unless we knew what this is supposed to be. But to keep that error from happening, I'm going to set this base on the outside edges here so that it's no longer going to be part of that problem. So it's going to be here and all around the base, and this is going to be the top of it. So what that was just basically some sloppy compilation that these people did for us. And then I'm just going to go back and repeat that triangulation contour command. I'll say okay. And now that particular set of errors will go away. You'll still see those vertical edges. I've got some more crossings. Here's one that's only 0.08, and it's right in here where they, let's see, zoom to zoom in. It's right where, and if we keep zooming in, see what they did is that it went just a little bit past, and that's where it crossed. And so you could either just drag it back or trim it off, things like that. We're not going to worry about fixing all that. I'm going to just let it go. Now you can see because we use those break lines, if I turn all my layers back on now, and I'm going to freeze these break lines and the points. Now compare the contours. You got those green ones. We've got the white ones and the red ones. Now we're on a 2-foot interval. They're on a 1-foot interval. So that's why you'll see the greens in between. But you can see with the little exception of a couple of places, it matched it up pretty nicely, except, and also look up here, you see that retaining wall from that loading dock has been modeled pretty nicely. If we view that now in our viewer, there's our contours. Now these contours are just, they're automatically being displayed in real time. But notice how it's picked that wall up very nicely. And not only that, but look at the curb definitions. It's got all of those curb faces and curb tops. You know, they're little triangular wedge curbs. That's the edge of a building through there, maybe an elevated something or other. So, and there still may be some issues, but by and large, we've modeled that surface exactly the way they modeled it. And now right in here is that little head wall. You can see that come into play. Over here on the edge of the road, you can see that's a nice little flat walking area. So it's a much nicer way because we've taken it from all the break line data that they used. So consider that when you're building these surfaces that you might have a bunch of drawn contours, and the temptation might be, well, I can just, you know, build my surface from the contours, and that's going to represent my existing ground or even my design ground. It will, but it will only consider the data that's included in those drawn contours. And you may have other data, like all these points that are out here in this area and all of those break lines. So if you've got the better data, use the better data. If you don't, some of those switches that you have, like minimized flats, if you're using contours. Now, I generally don't have that on unless I know I'm coming from contours. There's another one, densify break lines. If you've got one edge that has an elevation set here and you go way over here and an elevation set here, if you don't densify that break line, all the triangles are going to, you know, from one side, they're going to all hit that point over here, and then they're going to all start flying up to this point. You're going to have this giant, massive triangle. And it may be okay, but it tends to make a little bit of weirdness in there. So I generally do have that set on, and I put it at some appropriate interval. So it goes through and lays in those points along those features at that interval, but only in memory. It doesn't add it up to our drawing. It doesn't hog up our drawing. So that's generally the way that you should think about these. Okay. Now, when we come back, we're going to throw in a little building pad and just grade the building pad, and we're going to treat that as a design. And then we're going to look at the takeoff way of modeling this information. Okay. And show you how the colors work and how when we set the elevations and have it compute the, you know, the materials. And then we're going to tell that that building pad, for instance, might have a certain cross-sectional structure like rocks and or stone and you know, subgrades, things that go underneath it. Maybe it's a 8-inch thick concrete pad, and you can see how all that stuff can get pulled out of that information based on that takeoff method of doing the actual surface building and modeling. Okay, so here we are about 13 after. So let's go ahead and we'll take our full hour. Let's come back at for us East Coasters at 1:15. Ryan, it would be, what are you at? Are you at 9:15 now?
Yep.
So 10:15 after lunch. Sorry you're having to eat lunch so early. But we'll come back from there and then take that other approach and see what that can do for us and see some different methodologies. Oh, by the way, what I was going to show you guys too is, remember I set that I set the coordinate system to match my PA South. Well, one of the options that I can do, I'm going to switch to my GIS module. And if you have that, you've got a tool here under images that you can place a Google Earth image. You can also place these other image files. I don't have any, but I'm going to place a Google Earth image. And I'm just going to call it T3. You have to give it a name because it creates an image. And I want to pick the boundary, say, from the screen. From a map will take you out to the internet and let you pick it off an internet map. I'm just going to come down here and I want to try to get enough to where you can recognize this area. And there's no high resolution available there. We'll go with the medium and we'll say, go ahead and say, okay. So this is going to lay in an image. And there it is. Now, for you Greensburg folks, can you, I know I'm giving you no clues, and it's probably not enough to really look at here to see. You'll recognize it as soon as I tell you where it is. This is the Breezewood interchange off the turnpike. Okay, and this is where you come down here and like right in here's that little travel plaza where you can go in and get food and such. And then you come down here and you turn up this way to get on I-70 to head toward DC. And so this site was right in here, some of this stuff that they were doing some reconstruction on. Now, one of the things that that does is keep in mind when you do this, this is a Google Earth image. So, you know, you can see, see if I can find some of the inlets. Let me back out and tone this down a little bit. So if I'm looking, say, yeah, here's an inlet, for instance. You see that green inlet, and then you see the black shadow from the imagery. So you see it doesn't quite line up. And if I look over here at my parking lot, you see how that misses that corner a little bit better? That's because this Google Earth image is not survey quality. So this is just a way to sort of help you, you know, make sure you're in the right area, that kind of stuff. However, there's another tool that you've got. If you have the CADNet module, which is this one right here, and it's under this raster menu, and it's called Rubber Sheet. And so when you do a rubber sheet, what it's going to do is it's got this image. It's now, it has been set to current. And you can say, all right, I want to go from, I'm going to turn my snapping off. So I'm going to go from that corner up to, say, that corner, and that corner up to that corner. And I would just find places that I can see. Here's, maybe I'll go from the center of the inlet up to the center of the surveyed inlet. And let's see, there should be a couple of others, maybe some poles. Let's do another set of parking lot corners over here. I see a corner, oops, corner here to here. And see, I'm getting off the edges of my survey data. Up here's one. So anyway, you would find these different places and set those in, and one, and however many you do is going to determine, you know, how accurate this stuff is going to show up and how it's going to rubber sheet. into play. I don't really see a corner there that I can use. That corner is the photograph's too fuzzy. I think I already did those. Maybe down here, that one's fuzzy too. All right, so let's see, right in here's one. Say from there up to there. I've got some dirt spilled over that one. I can't really figure. All right, so no, once you've done that, you hit OK, and it's going to actually go through and physically warp the image and move it into place. Now, if I go back and look at where those inlets are, see how that inlet lined up? And up here's another one that I didn't set for that point, but now you can see the back of the curb has been warped into my survey data. So it's a nice little tool if you're needing something like that to modify these images that you don't have readily available. Now, if you happen to have digital orthophotographs, those are survey grade and you don't need to do that kind of information. But that's just something that you might be able to take some advantage of. I'll go ahead and just get rid of that and we'll put it back there. We'll save that. And now we've managed to go an extra 5 minutes. So let's come back at 20 after. First of all, any questions to this point? Everybody good?
Good.
Good
Pretty
so
good.
far. I'm definitely gonna need you to show me that Google Earth image again, because we do a lot of dump sites and
Yeah.
that's gonna be
Okay.
beneficial. But we could do that after the break.
Yeah, we'll come back after lunch and do it. Just remind me if I happen to forget it. Do you have the GIS module?
Yes.
Okay, so that does require that to be able to do that. It might be, let me take a quick peek under the construction module. Don't really. And there's nothing there. I don't see any I don't see any image stuff. Yeah, so that would take the GIS module to do, or even if you had the CADNet, can you place is the other thing you can cut, you can adjust. See, CADNet also does this raster to vector conversion in case you have a scanned PDF or a scanned image file, you can have it create the vector drawing for you. Yeah, I don't really see any placements of imagery under CADNet. So as far as I know, that does require the GIS. So we'll leave it at that. And remind me if I forget, we'll take care of doing that when we come back. Now we're ticking toward 25 after, so let's make it 25
This
after.
meeting is being recorded.
Okay, so all right, now if you, Matt, are recording it, again, I'm also recording it as well on my end. So, and everybody gets links to those. I don't know if anybody was missing when we talked about that in the morning. You're welcome to do so, but there's no real requirement on your end.
I was just
Yeah. Oh, you swapped into your computer. Looks like. All right. Anyway, we'll see everybody back at 25 after. I'm going to stop the share. You'll see that come back up. I'll now pause our recording and I'll see everybody at 25 after. Oh, good.
I just happened to look up and I didn't see it on. I'm like, you even said, hey, remind me. I'm like, you've been helping us out. I'm like, I might as well help you.
Oh, I appreciate that. I am so sorry. I was so set to do that. And I got into that, looking at that file that came in right at the last second and I forgot to turn it on. I do apologize. Anyway. Okay. So, all right. So I've got here, and let's say under this layout tab, maybe I'm going to let's rename that to, we'll just call it site plan. Whoops, let's rename that. Again, without using my capital letters. All right, so maybe I set that up to be, you know, this viewport is going to be, say, inch to 20. Well, that's a little too tight. Let's see, an inch. Well, no, let's leave it at inch to 20. But let's set this up to be a, instead of a letter size, we'll make it a an NCD, which is your 22 by 34. All right, so there it is. It's set up, and then I might have this as my, as at least one of my viewports. This will be my slide area, and maybe it's over here, and it leaves me room for notes and things like that. And I'm going to set this standard scale of 1 to 30. I'll set that also 1 to 30 for my annotation. And oh, then, you know, I might want to use this. Okay, see, monochrome and display. So now it would show up like that, and I might have labels and text down here, maybe we'll just call that, you know, site plan. Oops, PLAN. Oh, crap. And let's see, we had that set with a text style of mono. Let's change that to standard. And let's say maybe we go to our setting here. By the way, it also does XREFs here as well. But let's see, we got standard, which was using that text. All right, now remember I've got two files open. When I use my layer manager, which I think about, I see over here in the left two different files. The one that's currently active is boldface, and it's open there. And if I open both of these, if I look at, say, this text styles, for instance, there's that one called standard that uses Arial. Now in Design Center and AutoCAD, you could find these things, you drag them and drop them into your target file. But in here, you're just going to take the one you want and you're going to drag it and drop it over on to the same category. If I can get it to show, there's my textiles. You drop it down here on the same category. And then you can see, let's see, there's standard. If I may have to, I can't delete it. All right, so I can't, that particular one, because it was already defined. Let's see. All right, here's one CG fixed width that uses monospace, and it's not in this one. So I could take it from here and drop it into text styles here. And now let's do also this layout site plan. And I'm going to put that into site. I'm going to put that layout into my other file. And then when I close this back, I'm going to go to that other file. And you see down here, I've got this site plan. And of course, I've got this not pointing to the same location. You know, so I would have to, you know, reposition it here and then, you know, set it to be, you know, there's my 30 feet, and then you could lock it here over as well so that it doesn't doesn't jump around on. So that ability to do that, and you can see I've also got, remember that style that we copied over that was called CG fixed width? Then there it is. I've got it available. So if you got something in one file that you like that you want to bring over, you don't have to open the file and do a save as and give it your name and then do all that kind of stuff, or you don't have to, you know, try to copy and paste and do things back and forth, which you can do. But that little tool, this layer manager, is what it's called from the view menu, but it's so much more than that layer manager. And especially if you have other drawings open, you can transfer that information back and forth. All right, so that's available.
You can transfer like 3D line work and like layers and stuff from one to the other.
Only layers, and it's just the definition. You can't get the
Okay.
from one to the other. However, there is a way to do that, and it works the same in AutoCAD and in IntelliCAD. Let's say if I'm here in this civil, and let's say we've got, I wanted to take all of the building footprints, for instance. So if I select one of those and maybe now do a right click, select similar. All right, so they're now selected. I've got on a right click again, and I've got, you can also get it from the edit menu, but you see this thing called clipboard, and this is how you go back and forth between different files and different models. Is you can go to the clipboard now, and you can say copy. If you just say copy, it takes the center of everything you've selected. But if you copy with a base point and you give it a point of reference, let's say that point, let me turn this back on. Let's say I want to use that as my reference point. Okay, so that's now been placed on the clipboard, and I can then go over here and say, right click, clipboard, either paste to original coordinates. So if I have something that is, you know, matching up, or I can just say paste, or even paste as a block. But if I say paste, you see it's ready to go wherever I want to lay it in. And there they are. All right, so that's how you can bring across drawing entities, you know, the lines and text and things like that. But what this does, it lets you bring across, now you can do, for instance, blocks. Let's see what kind of blocks we might have. Nothing in there really. But we have some defined in here, like a light pole, a guy, and maybe a sign. I'm just control clicking these, and here's a tree, for instance. So if I put those over into that other drawing, because it didn't have them, then when I go back over to that other drawing, I can now insert those as a block. And I would just say draw, insert, and now it's listed. There's those things. There's a tree, for instance. And I'll unspecify the rotation and scale, and I'll just put it, you know, where I'm going to put it. I'll put a tree out here in this guy. And, you know, you can put it on whatever layer it needs to go on. Other different things, but the block definition is there. Okay, and then you could repeat that, do it multiple times if you wanted. All right, so that's just some additional functionality you get in the IntelliCAD version. One of the things I really like about that version, that and the fact that it's usually a lot more stable than pure AutoCAD. For whatever reason, I'm not trying to throw shade on AutoCAD. I mean, it's a fine product, obviously, or IntelliCAD would not have tried to model themselves after it. You know, that's that's the whole point behind it. So those are some of those tools and tricks and things that we can get into. All right, so let's talk about, I mean, I wanted to bring this guy back up. So if we had, for instance, that, and I'm going to do this from the civil menu since you guys have that, I'll do it from SiteNet. Here's an example, or let's, we're going to draw a little building pad out here. So we're going to, let's just draw a rectangle. And this is from the draw toolbar called a rectangle, or you choose it from the menu, draw a rectangle. And I'm just going to come around here and say, I'm going to put a point here and a point here, just like that. Okay. Now it just got placed on layer 0. So I would put that on if I had one here. I would normally put that on a C building footprint layer. I don't have that layer. So I'll just go and make one, and I'll call it C-BLDG-FTPRT for footprint. We'll make it blue, and we'll give it a little bit of heft. And then we will change that to be on that layer. 3DC building footprint. There it is. All right, so there's our building pad. Now, how do we make that a building pad? And you don't do that off this SiteNet menu. Let me get back to civil. There we go. You don't do this off of SiteNet. There's nothing here that says make that it has to be at its proper elevation. So we have to set it at elevation. You can do that by this 3D data. You can set polyline to elevation, or you can simply select it and give it an elevation in its properties. Well, that's one thing that you can do with it. Okay, and so you can create this stuff just as this drawn outline. You would elevate that and leave it alone. But to make it really sort of tie in the way it's supposed to tie in correctly is we want to, we can do this a number of ways. You can offset this. So let's give this an elevation. I'm going to give that an elevation of, let's say that's 1314 and a half. That's about where it would be, sort of right on the ground in the middle. So I'm going to just change its elevation here to 1314.5 or whatever it may be in your case. So I now have it there. I can verify that it is indeed at that generalized location. It's underneath it in the back, and it's above it in the front, that sort of stuff. All right. So we've got that set at an elevation. Now there's a couple of ways we can do that to set where does it intersect the existing ground if we want to make that building pad have, say, 3-to-1 side slopes coming up to this pad. And obviously you'd have more than just this outline. You'd have, access roads and all kinds, sidewalks and different things. But to be able to generate that, to create that as a pad to show you where those things are going to intersect is using a command off the surface menu called Design Pad Template. And if we choose that, we're going to target a surface file. And if we have a closed polyline, we're going to, what the heck? Oh, I need to uncheck this multiple pads. That's what I left it from last time. So I'm choosing a surface file. I'm going to the outside. So I'm not doing a pond. I'm doing the pad. And we'll go by a ratio. We'll do a 3-to-1. You can calculate earthwork and the pad surface and all that kind of stuff, or you can just do that after the fact as well. I'm going to round the corners. I'm going to draw these side slopes, and I'll put them every 10 feet. And I'm just doing that so I can get a better visualization sense. You can also trim the existing contours inside the pad. No, I'm not going to do that either. I'm just going to put it on a layer called pad. I'll say, okay. I'll pick my pad polyline. And it wants to know a target surface. Well, that was my T3 e.g. break lines on points. And now it wants to know a slope ratio for fill. I'm going to make that a 3-to-1. And then it wants to know a cut ratio. I'll keep that also 3-to-1. And then there is the resulting geometry. This is all this is doing because I unchecked those other things. And do I want to adjust and redesign? Well, let's say, yeah, I'll do that. I'm going to change that from a 3-to-1. Let's go ahead and use a 6-to-1 and see how much that gives us. No, I'm not going to offset the top. Okay, so that'll be a little better. So a little smarter. Now adjust parameters, redesign. Nope. I'm happy with it. All right. So there it is. And if I look at all that stuff in my 3D viewer, again, because I do this all the time just to verify. And there's going to be what it looks like. The blue lines are in fill. The red lines are in cut. Okay. So now what if I wanted to make a surface out of that? Easiest and quickest way is I'm going to isolate the layer. I'm just going to pick one of those lines. So that that's all that's showing. And I'm going to just triangulate and contour. And off the surface menu, triangulate and contour. And then I would choose this as my inclusion boundary. That's one of the options to check on. And then just select all your data and you would build that surface. All right, so we won't go through that part of it, but that's the way you would do that. And then you could use triangulation file utilities to merge this surface into this surface. And that's the way I do a lot of my designs. Like maybe if this were a parking lot and maybe it had a slope across the top and it wasn't dead flat. And I would make that as a surface. And then maybe I would draw in parking islands and I would lay those I would draw them in as 2D polylines, and then I would go to 2D to 3D by surface model, and I would drape those drawn 2D polylines that represented those parking islands, and it would lay it right down on top of that, whatever that resulting surface was. And I would then rebuild that as an inclusive surface. So I don't have to try to set the elevations on all of those things if it's all just relative to that surface. I, draw them as 2D, drape them on the surface, and then go back and rebuild the surface and include the islands this time to make that happen. Okay. Now, another reason we like using this particular command is on the surface menu where we did design pad, you can actually edit the pad, and you would choose the pad. And you get this little docked thing on the side where you could change. Now, let's say instead of 6-to-1, I'm going to cut that back to say 4-to-1. And then once I make those changes, I would process, and you'd see it redraw itself. Now it's reprocessed. Let's say, well, I needed it to be a different slope, process that again as it redraws that. Now, you can also, move the pads. So we could say, just pick it up here and move it. And then once I reprocess, everything goes along for the ride and recomputes and redisplays. Now, notice here, my volume, I've got 353 yards and 1328 yards. That's my cut and fill. It should have labeled that, but it didn't. But if you want to do a balance, if you need to balance this so that your cuts and fills are going to match, you would say balance, and you give it a tolerance, say that the closest 10 cubic yards, let's say closest 2 in this case, and I want 0 of haul in or import and 0 haul out. So I'm going to balance my cut and fill. So I'll say okay, and it's going to redirect that. And what it did is it changed that elevation right up here, my pad elevation, to where it now met 766, 766.4. It's exactly the same. Do a report, it tells you you know, your cut and your fill. Okay, so you can do that. You can rotate, you can, you know, move a vertex so you could, you know, pull a corner out or move it in and do all kinds of things with it. Now, here's one thing that I like to tell people that a lot of people don't think about when they hit this balance. Let's say I needed, you know, say 500 yards over on another part of my site. And maybe I'm designing this outline, maybe it's not a building pad, maybe it's a borrow pit. But I want to set the elevations of that such that I'm going to get 500 feet of or 500 yards of material that I can take out of this and carry off to another part of my site. Well, that's balancing just like it is to set it to 0, 0. So I'll say, okay, it recomputes. And now you can see in my report, I've got 1,000 yards of cut, 500 yards of fill. And so that leaves me that 500 yards to carry away and use somewhere else. Okay. So I'm going to put this back at 0. And show you another thing that we can do with it. And at this point, you can also write the 10. So that's another way to get the surface made pretty quickly. Other than, go
When
ahead.
you hit that right 10, is that just making the surface on that pad
I
and where
think
it tied
so.
in with the slope?
Take a
Okay.
look. I will call it pad. In other words, does it incorporate the existing ground? And my response to that is I don't think so. I think this pad tip, yeah, I can see from the shape of it.
Yeah.
It's just that. Okay. So, yeah, so that would be just as if I'd isolated and built the surface myself and checked it out. I tend to be a little more control freakish. So I like to do all that stuff sort of separately and do it and check it all out before I'm happy with it. So that's one way you can do that. Now I'm going to delete that pad. And now I still got this and it's now at its new elevation. I'm going to, oh no, it kept it down to 0. So I'll put it back to 13, 14 and a half. Let's make it 13 and a half since I moved it. All right, so that's now sitting there at that elevation. There's another way of doing this as well, and you don't have to do that design pad. And by the way, design pad is not only for closed figures. You could say, you could have a, you know, it could be the edge of a parking lot, or it can be the side of a road that only goes from a start to a stop. And design pad, then it's going to ask you to pick which side you want to go for that side slope location. That's the way we do ditches a lot of times. We'll set those bottom of the trench down at their right elevations, drape them on, you know, where they're supposed to be, follow the same slope as the pipe. And then we can do that design pad template and go off to the side with you know, a 3-to-1 or whatever to intercept the existing ground. So the other way of doing that is with this, that's a 3D polyline. We can offset a 3D polyline. Now it is not a 3D polyline, it's a 2D polyline, but it has elevation, so it's going to qualify. And what we typically do this for with intervals, for instance, if I've drawn the face of a curb and I need to build that curb structure, I'm going to do interval and I'm going to do it several times. I'm going to offset it vertically 1/2 foot and I'm going to lean it back just a little bit, like a 1/10 or a 1/2 tenth or a 100th, whatever. As long as I lean back and tell it to go up a 1/2 foot, and it will, whatever, it'll follow those same elevations and just raise it up 1/2 foot and kick it back over. Then I'll do it again for that one and I'll go back 1/2 foot from that line, but zero change in elevation. So that's my back of curb. All right, so that's one of the ways to do it. But you can also, with this same command, tell it, I want to go to a surface. I don't want to use the this interval method. I'm going to target a surface. And so I'm going to say, okay. And do I want to round the exterior corners again, just like the pad? I'll say, yeah. Now, what format? By ratio, percent, or degree. And I'm going to do by ratio, which is what we had before. Here's the polyline to offset. The surface I'm going to target is that T3 EG break lines points. And we used, what was it, 6-to-1s, I think. I forget now what we wound up finishing. And which side to offset? I'm going to go this side. So there now is what would be the intercept line on that surface. And down in this part of it, it's going to be in fill. And this part up here is in cut. Now I've got enough just with those two elements. I would have enough to build a surface out of that. I don't have to have all those little side slopes, but you can see the difference in what I did. Now, if I look at this here, you see I've got 4 corners, and this one is going to have a bunch more corners. Now, watch what happens if I do this with my triangulate and contour. I'm not going to write the file. I'm not going to draw any contours, but I'm going to draw the triangulation lines here. And I will use inclusions, and I'm going to uncheck this, and I will say, okay. So here's my inclusion perimeter, no exclusions, and then I'm going to take everything and build a surface, okay? So you see what happened with these triangles? I get just these huge ones across here, which is fine, that's flat, but look at this triangle here. You know, it's, and if I look at that, say in my, well, I didn't save it as surface. If I look at it in my 3D viewer, you see right in here, I get this line here with all those points around it. Every one of those points connects out here to the only points it can find, which is that corner and this corner up here, but it found it, these skinny triangles across right here happened because it took that point and it looked over here and found this point first. There was nothing in the way, so it built that. That's why there's a little gap there. All right, so that would still probably model correctly. Okay, that's still probably, you know, it's nice and smooth surface like that. But if you want a little bit finer resolution on this, let me erase by layer. One of the things you could do is either densify this permanently by edit, polyline utilities, densify polyline vertices, or just simply go back to that triangulate and contour command and turn on that you want to densify the break lines. Let's go every 5 feet. We'll say, okay. We'll get my inclusion perimeter, no exclusions. Now grab my data. And now look at the difference in the contour. So now you see all of these points along that blue line, when every 5 feet, it's stuck in a vertex. But if I select that original line, you see it only has those 4, it only has those 4 vertices there, and that's the midpoint glyph, the midpoint grip. So it still only has that. So I didn't clutter up my drawing with a bunch of extra vertices, but the process of building this file now became such that it made those triangles a little bit more evenly spaced. And in this particular case, it probably would not have made a bit of difference. But
I like the pad template because you're not wasting all that like data with all those little triangles in the center of that pad because it's flat.
yeah, but I mean, sometimes the pad's not flat, so
Yeah.
you have to go to, so you get some in there as well. But the pad polyline, when we did the pad polyline, remember all those little lines that
Mm-hmm.
got down? Those have endpoints. It sticks up this one as just the four corners, but when I build the surface out of that pad, it still honored the endpoints of those side slope lines. And again, you set the spacing and is however dense that you want to make that surface. Okay, so that's another method of doing that is you can just offset the edge and then you could draw in some lines. Now there's a couple of other little things to think about here in terms of building surfaces as to what you're doing. And what I'd like to do is show you that if I can find where I put it. Here we go. Let's see, is this? No. No, not that one. That's this one. All right, when you may see something like this. You may encounter a situation like this. And this was a series of articles that I wrote for American Surveyor magazine several years ago. Maybe your design plans called for a building that looked like this, and it has a particular elevation, and I had a 10-foot sidewalk with a 2.08% cross slope from the edge of the building to the sidewalk edge was 2.08%. And bonus points for who can tell me why 2.08.
I'll guess ADA.
No, good guess though. But that is simply a 1/4 inch per foot. And that's what is typically, what most builders they won't pitch a roof any flatter than that because they want the water to drain. So although most cross slopes on roadways are 2% instead of 2.0, that's all that was for. All right. And so this might represent a parking lot out here for the building. And these two edges had these elevations, 100.5, 100.5. So it's dead flat across here, even though it's 2.08% below the building. Okay. But the building's flat, so is this edge. But then it goes from that point down to this edge at a -3%, and it goes from this point down to this edge at a -1%. So it doesn't fall as fast. This falls down. There's my low point, 97, 98, as opposed to 99, 66, etc. So what winds up happening there is if I just model that with no densifications and any of that kind of stuff, we wind up with a situation like this, where this is the resulting surface, 98, 99, 100. And you can see it formed, you can tell by the way these creases are that it built the triangles, from this upper left to the lower right. And that's how it did this 3%, did this 1%, and then it made the triangle corner to corner to corner. And the same thing over here, and that built that surface. Now, if you go out and try to construct that surface, you're going to have a crease in it from there up to there. And maybe that's what you want, but there's going to be a visible crease. Okay. So here's what a lot of people, mostly on the surveying side of the world, try to do to get around that. They say, oh, well, I'm just going to turn on contour smoothing. And so here's contour smoothing applied to this same surface, And the contours look all nice and smooth. That's all relatively good in terms of how it appears on the drawing. But if you load that surface up on a dozer, it's still going to put that crease in that parking lot down there with this nice triangular slab and this nice triangular slab right down that corner. That's still, you don't, when you turn contour smoothing on, you're not adjusting the surface, you're just adjusting the drawn contours. I almost never turn my contour smoothing on. I almost always leave it off because I can always tell when I've got an issue. So then what you do to fix that is, here's a case up here in this instance where we said, all right, densify these brake lines every 5 feet. And so it put little vertices all the way across there every 5 feet. And now you can see the contours represent, in general, a little bit better. It'd be a nice smoother surface. But notice these jiggy jaggies, right? Now, a lot of people will do a couple of things here when they, if you guys are used to editing your surfaces once you're done, what's the approach to try to get those to go away? Do you know? You ever heard of swapping triangle edges?
I've heard of it, but I've never used it.
Well, good. Don't get in the habit of it because it's still not the solution to how you want to make that happen. But what causes it to happen is that you're building triangles from this edge all the way across to this edge, and there's nothing in between for these triangles to help resolve. So in this particular instance, because this is, this is going to result in a curved surface. It's got this 3% down and 1% down. It's not a slab. It's going to be warped, okay? But we don't want it to warp like this, because you won't go out there with the dozer and go, chitter chatter as you're building this thing. So how do we make that happen? We need to draw a brake line or two across there. And so here's what we wound up doing. And the article explains all this, but I basically drew in 2D polylines corner to corner. I then copied them up, actually arrayed them every 10 feet. And so I had these lines that you see down here all the way across the width of my parking lot. And then I went to my 3D data menu and chose 2D to 3D by screen entities, selected all those lines, chose these edges to drape them on, and it set the endpoints of each of those lines where that happened. Then when I rebuilt the surface again, I'm going to include these lines. Now, if I don't densify these polylines, I still have that problem of just using corner points, and some of these would work and some wouldn't. It's just, sort of random. So I had it densify every 10 feet along all of these things. So along the edges and along these crossing lines. And so now when the surface gets built, all of my little triangles are nothing more than, say, this corner to this corner to this corner, and then this corner to this corner to this corner. And then it can only look up here and see this line, or look up here and see this line. It can't look all the way across and grab something over here or all the way up to that edge. It's constrained by what it can see. And this is the resulting drawn contours from that surface. No smoothing. That's the surface you want to build, and that's going to be that actual sort of curved, warped surface, that parking lot. So sometimes you have to, analyze some of this stuff and see, this is sort of an extreme example, but it is, something that we need to be aware of. And if you wind up seeing things like this, understand how you can make that happen. You got to break up these long, skinny triangles instead of trying to swap edges. Because what happens if you swap edges, you go in and you swap this one and it takes that kink out, but then it makes this one even worse. And then, you chase yourself all over the site trying to swap edges to make those contours look smooth. And you're actually changing the way the triangulation is working. So, try to figure out some means of doing that. And Matt, I noticed on your file, that's exactly the kind of stuff that you were doing. You're putting in those controlling edges
Hmm.
and doing that.
Yeah,
Now,
kind of like force those triangles to go where you want them to go.
exactly right. Now, when you do that though, and you build it from the takeoff method, the SiteNet method, and you're just doing it based on the layer membership,
Hmm.
if you have those long lines with no intervening um, density points placed along them, then that could be what triggered that to happen. So if we actually, in fact, we can take a real quick look at that. Let's go.
Yeah, I like went through in some spots too. I'd like densify to like 1 foot, or something like that, and just little remote areas to kind of like get the triangles to jump better.
Yeah. So you can, let's see if we had this, see that line is, there's a few in there. That line's got a little, or that's that particular line. Let me see that one. That's the top of the wall, so it's like that. But um, so if I were looking at that now, which is, oh, there's the line I'm looking for. So if I select that, you see where those points are. I got points at the ends of all of those. That's good. I got a few in there, but let's see if we actually did the densify polyline vertices. And I'm going to take that particular break line and let's do these as well. I'm going to set those to every 2 feet. I know that's kind of nuts, but that's going to give me a little bit better control. I might even tighten it up, but so you have to do that in, let's come back to this design. We will change it back now to layers. And save that. And now if we do it, now it still may be a problem, but that could catch, right in there where that was causing a problem and see. So if we then made our design surface, I had that one crossing, it's tiny, I'm going to ignore it. So now when I view that final, let's take a look and see. Look at that.
Hmm.
So that would maybe be a way, instead of necessarily having to choose to pre-build the file, although I tend to pre-build the file, verify it, and then throw that into my layer definition list. But if you ever get cases like that where it does jump the line like that, densify that polyline, and you don't have the option like you do under surface, triangulate, and contour, where you can check this box and it does it in memory. You have to actually do it to the line work itself so that it then, as you can see, it threw in all those extra points. And that managed to force those triangles a little closer to home and keep it from jumping across. Now, I would also have densified that one and it would have been a little nicer as well. Let's take one last quick look at my surface. Turn this off and see how the triangles form. So there you can see this line down here across the bottom was not densified, but this line here and across the top of the wall, those were densified. So you see how it managed to force those up. So, if you had any other problems, you could even densify that line, this back one here, because you see these big slab triangles are what got built. Now, and they may be perfectly legitimate, don't get me wrong, because if that's an all constant elevation, this all constant elevation, that will be the resulting model, and that will be exactly how that gets built. So that's not an error to not do that, but it can clean up some errors if doing it that method, you notice those jumps, those sort of 3D faces that get built out there incorrectly. Okay, so that might be the first thing you might consider is to densify. And it sounds like, you've sort of done that on a manual basis. You went through and added some extra points to try to force it. But just go ahead and
Sometimes I'll draw lines. Sometimes I'll just densify the vertices of the polyline to get it to jump itself.
yeah, and not only densify the one that's in question, but densify its adjacent neighbors as well,
Mhm.
so that you're forcing both sets of triangles that come into that's supposed to be used as a break line. You're forcing everything to go to those same points in the same spacing. And I would do it. I've never had a case where I've had to do it any less than 2 feet, but I wouldn't do a 30-acre site, densify every polyline in the site at 2 feet. I mean, it's just too much, and it's more than you need, and it might even overload a piece of equipment. From file size, you would have to go and then, reduce the surface a bit to get it to work. Okay.
Mhm.
So, so that's a couple of ways of looking at that. Again, we did that design pad, so it would do this. You could also, you can do design pads. Let's say if I'm building a wall, for instance, I'm going to just draw a 2D polyline, and I'm going to go from here to here, and then maybe up to here. And that's going to represent the foot of my wall, the bottom of my wall. Now, I'm going to drape that on the surface. So remember how I did that was 3D data. I'm going to say 2D to 3D by surface model. And again, there's my surface. I'm going to choose that. And remember now, when I do that, I also, now you notice that vertical offset, let's say that was a water line. I could have put that 4 feet in the ground, and there's my water line. All right, so, but what I did was I put this in here, and all these little vertices are where it crosses triangles of that surface. All right, so that's what I want. It's draped on the line. Now, what about this point out here? Of course, it's reading the surface, so it read that out there. If I did this by screen entities instead and had it cross these lines, because it's out here in the open space, it didn't read anything for that, except for when you go back to settings, cross and configure, takeoff and site net settings, I told it to, at some point, maybe not here. Let's see. Nope. Under surface settings, I don't think so. No, it wasn't there. I wanted to extrapolate the endpoints. Maybe that was in the command itself. If I do by screen entities, yeah, there it is. So if I were doing it by screen entities, pay attention to this setting right there. Extrapolate the end elevations. If you don't, that stays at 0, jumps up to that elevation, goes to that, and then over here drops down to 0. But if you extrapolate, it will take that segment that had elevation and push that slope back to the start. It takes the closing segment and pushes that slope out to the end. All right, but we draped it on the surface, so it had data. So it's now there. And now to make this as a wall, what I would do is then I'm going to offset that just a little bit to set the top of the wall. Now there's a couple of things we could have done. Before we draped that and turned it into a 3D polyline, we could have gone ahead and offset, 1/10 of a foot, and then made the top where it was, and then set that top all at some elevation. But now that we've already done this as a 3D, we can also do that same command under my edit 3D utilities offset 3D polyline, this time by, let's go to a constant. I'm going to go to a constant elevation. And we'll say okay. And it wants to know down at the bottom the horizontal offset amount. I'm going to just say 1/10. And it says, okay, enter that common elevation. Well, let's make this wall, let's see, it's 15, 16, 17, 18. Let's make it 1320, 2.5, let's say. So we'll pick this and we'll set that edge. So now we've done that. We've got the top of the wall and it is sitting up. If I look at those two things, again, in my viewer, you can see, you know, one's on the ground and the other one's sitting at a constant elevation. So I now have the top of my wall and I need to set the back of that, you know, the other side. Let's say maybe it's a 2-foot wide, or to make it a 1-foot wide wall. So I'll repeat that command. Now it's also on this polylines toolbar. It's right there, offset 3D polyline. And I'm going to at this time make an interval. I'm going to say okay. The horizontal amount is going to be 1 foot. The vertical amount will be 0. I'm going to select that line and now go to that direction. So now there's the top of my wall. And I could, you know, that may be all I need, or maybe I would drop another one down on the other side to be the bottom on that ground. But, you know, if this is to be a retaining wall, I'm going to actually, you know, maybe I'm going to hold stuff back over here. So I wouldn't necessarily set that bottom edge, but it's now there. You can even do things like I can draw a 3D polyline and go from my endpoint to my endpoint to my endpoint. And I do this a lot to help me, just to help me visualize things. So I'll do it again when I go, whoops. When I go to view, and, you know, and usually maybe back out here, I'll have another surface maybe that I'm draping it on. But you know, this just helps me when I go to visualize this in my viewer. Let's get everything there. And so there, you know, and if I had a backside, I would have done those same little connectors, but you see, I didn't tie the top to the back, but that would actually build that wall when I go to add that into my surface. Now I should have, you know, something else behind it there if it were exposed. If there was a reveal of this wall face back behind it, I need a bottom slope down here to do that. You know, maybe there's just maybe it sticks up out of the ground out here an extra foot. So I would just offset this line, you know, 1/10 of a foot away and drop it a foot in elevation. In fact, let's go ahead and do that by interval, horizontal mount 0.1, vertical mount minus 1. And we'll do this guy over to here. And then we'll go ahead and put these corners in again, just for visualization. Go back and view it again. And now you can see, you know, there's that little bit of reveal in the back. You know, so, but somehow or another, I need that I either need that line or I need a surface, or if I'm filling behind this wall, you know, right to that top edge of the wall, that's, I don't even need this bottom line and those connectors. So, but sometimes you'll see this in a set of plans, you'll see a label that says top wall, bottom wall on both sides. So I just build those accordingly and set those in there, and you'll see the step across the top, where you might see up here, you know, a top wall and then another label that says you're going to step it up 2 feet or whatever. Now, Matt, you've done that on the file that you just showed us. So what is it? Let's say I'm going to put a step in this wall right in here. You know, say right there, I'm going to put a step in the top of that wall. What do you need to do to make that model correctly when you do that? Can you just break this stuff and then make that point exactly over top of that point?
No, you can't have a vertical face on anything. You need to like step it back a little bit.
Very good. I want everybody to understand that. You cannot have those vertical faces. There's a mathematical reason for it, and it's part of that Delaunay criterion that is used when it's triangulating. You can actually do it. It'll build it, and it will build a vertical triangle. But what happens, and why you can't have those, is if you were to try to compute a volume within that area, the way it computes volumes between surfaces is it looks at each triangle, and let's say the bottom is the existing ground and this is the proposed ground. It looks at all the triangles and it gets in this area, and it sits in any given triangle, and it finds the centroid of that triangle, and it shoots a line up vertically, up and down, until it intersects a triangle of the other surface. And if that triangle is completely vertical, it can't find a point of intersection because it intersects the entire triangle across that verticality. So it has to lean back just a little bit so that when it hits the triangle above it, it hits it in a discrete point, because then the way it works, it hits that point and then it subdivides that triangle into 3 triangles based around that point. It goes to each of those and drops lines down and hits the other triangles and repeats that process over and over and over again until it computes all those little bitty vertical cylinders that it has created, or prisms, actually, they're not round. And then adds them all up and comes up with the computed volume between those surfaces. And that's why you can't have it vertical, because when it hits that upper triangle, if that triangle is absolutely vertical, it can't find that point of intersection when that line comes up from below. It would hit the edge of it and just splay all over the triangle and can't figure out where it's going to go. That's also why you can't have overhangs, because if it hits a triangle up there, you're hitting it from the air side of the triangle, not the ground side of the triangle. And that would then screw up the computation, because at that point it tries to go back through the ground side and find the existing ground underneath it, and it's not there because you're inverted. Now, all of that being said, there are real cases in the world where we have vertical edges, and there are real cases in the world where we actually have overhangs. All right, so, but when we're using triangulation as our modeling techniques, we just aren't able to do that. They're not allowed. There's a way around that in some other kind of modeling software that models things as meshes instead of as triangulation networks. It's beyond this course. It's beyond what Carlson can do in that particular case in terms of a design mesh. Other software can do that. And it's usually it's software that does things like building teapots and tunnels and toy trains, because it uses surface meshes, and so it can compute those. Now, Carlson has a sort of way around it, and I'll show you where it is. We don't really have anything set up to demonstrate it very nicely, but when you run triangulate and contour, right in here in the middle part, let's see, is this? Yeah, right here. See where it says pick reference plane? So that allows you to shift what is normally a horizontal plane. You can pick a reference plane to model the overhang so that it is no longer overhanging. So you would basically put a plane down below it that has a tilt to it such that when it computed something vertically, it's going to hit the overhanging elements, and in relationship to the tilted reference plane, it's no longer overhanging. It lays back from its quote vertical, which is just that normal line between that reference plane. Now, I say that Carlson has a sort of way around it, and this is the case, but it only applies, I mean, it would apply to everything you select. So if you selected a reference plane that was tilted so that you could model the overhang, it's going to model everything from that reference plane. So it's not really a solution, but it's there. If you wanted to make a little itty bitty surface based on, you know, that some localized areas, you could do that. It's not real useful. I wouldn't waste your time trying to make it work. It's more headache than anything else. I would just trim back your overhangs and you know, not worry about it, or just flag up with a, you know, a red circle on your model and try to, you know, figure out a way around that otherwise. Because, but that unfortunately is the limits to that. Now, here was another example, for instance, using that either offset 3D or design pad. If you still have your, like your building pad, or let's call it a parking pad. In fact, it says parking there anyway. I'm going to draw in a 2D polyline. And again, I'm not worried about layers in this case. I'm going to go from here down to here. All right, boom. And I'm going to put that on the surface, or actually I'm going to give it a start and stop elevation. We had this one at, say, elevation 13,1350. So I'm going to start this one at 1313, and I'm going to drop it down to 1310.5 or so. So I'm going to do that this way. 3D data, 2D to 3D by start and end elevations. Put my polyline, and now at that elevation, I'm going to give that say a 13, say 12.5. We'll give it a foot deep. And down there, we're going to say, well, let's do a P for percent. I'm going to drop that down at a 3%. Elevation. So it computed the elevation at 1308. All right. So selecting the polyline, I'm done. Enter to end. All right. So that now might represent a, you know, maybe I'm at a site and I'm going to put a ditch through the site, a little drainage channel. Maybe this is a borrow pit and I want to make sure I can drain the water out of my borrow pit. So I'm going to now do a 3D offset because it's now 3D. I can't just offset that. Let's say we'll make it 2 feet, but I'm going to go by interval. I'm going to say the horizontal amount, I'm going to go 2 feet across. So it's 2 feet bottom width. And I'm going to say my vertical offset is 0. I'll take this and go to that side. Now I've got the bottom of my ditch on both, you know, and they're parallel to each other, but they do have elevation, which we can verify again. And you may notice, you may get tired of me doing it, but I constantly going back here because I have been bitten by this thing before. So, you know, it's actually down there and it's got some elevation. I meant to actually choose. I'm going to go back here and actually choose. I also wanted to choose this guy. There we go. So I can see that if I look at that just edge on, let me turn these contours off. So if I look at that where the building pad's level, you can see I'm starting here at the top end of my pipe and I'm going down. So I'm actually, down at a slope, whereas my pad was actually flat. Okay. So that's going to be my ditch through my little graded area here. How do I set, where does it come up and hit the existing ground now? Or if I had this as a surface, it would do that as well. In fact, let's see, 1308. Yeah, that's going to be too big. I'm going to actually make that into a quick pad surface, or did I make a pad surface? I did, I think. Let me look at that pad surface if I've got it. Here's my pad test. Let's make sure. I'm going to go to my model. I'm going to pick these things to add to it. I'm going to turn those off, and yep, there I can see. And if I turn this and look at it, I see that my pipeline is actually underneath that surface, whereas this is on the surface. So that's going to be my target surface. So remember, like we did the building pad for this actual closed polyline, we can use design pad template. And this time we will we're just going to take this as not a closed figure. We're going to target our pad test, and we're going to come out of the ground at, well, let's just do 1-to-1 side slopes on our ditch. So 1 and a 1, and we're going to go to this side. Nope, I'm not going to readjust, and I'll do the same thing, and I'm going to come from this side, target my pad surface 1-to-1 on that side. Now, if I wanted to make this ditch a surface, I would just either close that off. In this case, I wouldn't really even need to. I could just do it without picking without picking the closing boundary, the shrink wrap. But that now you see would be the ditch that lays in there. In fact, if I go in here and lay in that surface on top of it, you can see now again, let me turn the like the backs, let's see, shade the front, I'm going to shade both sides. So you can see the line work. And see, I haven't built the surface out of that pipe trench yet, or that ditch yet, but there it is. And it's sitting right where it's supposed to be. So I could use that then to drain this particular area with a little drainage ditch out. Now, obviously, if I were going to make this into a surface and then try to merge this surface into that surface, I'm going to have a problem right here because it's going to put a little wall in there. So I'd have to generate some line work to get me out of that edge and, deliver me on out into the daylight. Same thing here. I might put a line across, here to here to here to here, and then offset that back up to hit this surface right at the surface intercept. And then connect that accordingly. In fact, I would do that. I'm going to draw another 3D polyline. I'm going to go from here to here to here to here. I'm going to offset that 3D polyline, which is here, to a surface this time. And I'm going to, doesn't matter about my corners. And I'll do this as a ratio. And we're going to take this We're going to target our pad test. And we'll put these in at a nice flat 10-1. And we'll pick this side. So now, when you look at that mess, that's actually where it comes out right on the pad and then starts, and you could, you could extend those out and do all that kind of stuff to catch that, but that's really all you need. In fact, you could go to the effort to draw the bottom line from there all the way up to that corner. So that would close that part out. In fact, let's go ahead and do that. And I see up here, I missed that corner just a little bit. So I'm going to go here to my settings tab. I'm going to set my drawing rotation to match it. Now when I exit, I'm looking at that same perspective. So I would come in here and I see what it did. So I need to, just drag this guy out. And then I'm going to remove that vertex. Same thing I would do here. Drag this guy out. And then remove that vertex. And then I might, to refine it a little nicer, come back in here and take it from this bottom edge all the way up to this edge. Do the same thing on this side. And I could densify that some if I wanted. No particular need. That would define that very nicely to come up and it would hit. Now it's not hitting this existing ground, it's hitting the pad elevation. And then I would do the same thing down here, but I would not, try to bring this stuff back. I wouldn't try to take that line and bring it to that pad. I need to take it out to where it's going to hit something out in here. You see the process? And then you could build that as a surface and merge it in. In fact, we'll do that real quick if let's isolate that and let's build a quick surface and we'll call it a ditch. I'll turn off the drawing the lines, no inclusion areas and no shrink reproductions not needed because I don't have any insets. Densify the break lines every 5 feet. We'll say, okay, we'll take this data. Boom, there's a ditch, there's a pad, and I can go to surface, triangulation, file utilities. I'm going to load up as my base file the pad. I'll go next, and I'm going to merge in that file with these. The second 10 is inside, the current 10 is outside boundary with transition. I will bring in the ditch. There it is. I can see it. Much like we did before, you can see how it goes right there at the ground where it starts and it comes down here, makes a nice vertical wall. Okay, so I can put a pipe through there and drain it out or whatever you want to do. I could then do a save as at this point and call it pad-ditch. It's now saved. I'll exit the utilities. I will view my pad ditch surface file and you can see how it has put all of that stuff in. It stitched it right into that surface exactly as your intent was. Okay, so now you notice these triangles here were formed, from this edge to this edge before it allowed the triangles to shoot over here across the way. And that's because this is the result of the merger. If, however, instead of doing that merger, you did this, where you said, let's build a surface. We'll call this one, oops. Pad ditch 2. That's fine. It's all good to go. We'll say okay. And now we'll grab this just as data. It's now built a surface. And if I look at that surface, it's going to look very much the same. But you see how the triangles are a different shape now because those other triangles had already existed. But when I did the merger, all it did was take the triangles that were being affected and it merged them in. And notice down here now, because it wasn't part of the merger, it just went from that edge and started finding this other edge. It didn't close that off with a vertical wall, which was what my merger did, because I said it's going to basically take this surface and cookie cutter it into this other surface, leave everything around the outside of that surface intact. In this case, it didn't. It built this information. See if I can get it to visualize a little better. Maybe not. So, in this case, it tried to go from this edge out to that edge at some kind of smooth transition directly in it because I didn't do the cookie cutter, which set that cap across the end of it. So just a couple of little things to be aware of that could affect, what you're trying to model. And again, let's not get too bogged down in the weeds with this stuff, but you can see, how this kind of thing would work. You could also, and this would be, what you would do if you're modeling a ditch into some irregular surface. Let's say okay, and I'm going to choose this original line, and I'm going to just go up to my existing ground. Let's do let's say a 6:1, and go to this side. So that now would be select by window polygon. And then I'm going to remove that original. And then I'll just delete that. All right, so that now would look like so. And you see the edge is not nice and straight because it's not hitting that flat elevation. It's actually riding the elevation of that existing ground as it hits out here. And so that would be, how you're putting, if you're putting pipe trenches in place, and you're targeting that surface at that outer edge. And if you use the design pad, now again, you can do that with, offset 3D to go to a surface, or you can use design pad template, and design pad lets you throw in all this extra visual stuff that might help you visualize some things a little better. And then you can hide, let's see if I turn everything back on and then freeze my break line. And then you could freeze your pad so it's not part of the drawing, but it's actually been used to build the surface information. Okay. Everybody good with that? To date, is any of this new for anyone? I don't want to spend a lot of time rehashing stuff you already do, so kind of help guide me with what you're looking at.
Some of the features are new. Like I said, when I did my Civil 3D days were back in 2011, 2012. So a lot has changed since then. There's a lot of cool stuff you showed that I'm like, whoa, this is kind of nice. So I'm glad this is being recorded so I could reference back to it.
Yeah, except for the first half of the afternoon. My God. Anyway, yeah, this is what we've been doing with these 2Ds to 3Ds and draping them on stuff. That's analogous to the Civil 3Ds feature lines. You know, that's how you would turn those into feature lines. And although we don't have a mechanism in Carlson to make a feature line be assigned to a specific named site so that it controls, we have to sort of keep track of that stuff separately as we need. But that's, you know, the closest analogy I can think of is to think of these as feature lines. If you used feature lines when you did your work in Civil 3D, sometimes we do, sometimes we don't, but most modern practice, you know, we are using feature lines. So, okay. So, Ryan, what about on your end? These are all tools that you normally use? You're comfortable with these every day? I don't want to make this a bore fest for you if you're not, but I also don't want to get too deep into the minutia that we miss track of some of the other stuff as well. How's this line up with your work?
Pretty good. I mean, I'm pretty comfortable with when I'm making surfaces off of points that are provided, or I'll just make a polyline that, you know, for the center line of the ditch,
Yeah.
and then give it elevations, and then do some 3D offsets. Or if, like, I recently did a path and I did a 3D offset and gave it slope going, you know, one direction and then the other.
Yeah. So you're typically using the 3D offset method, which is perfectly fine. Do you use the design pad template very much at all to do the same thing, or you generally reserve that for pads, or have you used it much?
I really haven't used it much. My hope was to get more, which we did cover some of it, is just we get surfaces, usually XMLs from the engineers that just have all those errors in them and stuff. So just going through and
try to fix the errors, or
fix where it, you know,
or
snapped
at
up to
least,
the top of curb and stuff like that.
or at least flag it and send it back to them and say, can you, you know, resolve this for me? Yeah, so those are good when you have those as well. One of the other things I want to show you about design pad real quickly, and it's, you know, we don't have the data set up here to sort of show it nicely in its completion, but if you look at this design pad template, one of the options is to not just take that line and push it out somewhere, but you can actually use use an actual template on these things. So if we do that, let me see where I'm looking for it here. To slope. Well, you can use different slopes for separate sides. You know, you can set, you know, 6-to-1 here, 4-to-1 there. That's one thing. But there's a way of, if I'm don't see it on here. Try this for a second. I'm going to pick the pad polyline here. It's going to target that. Let's go 6 to 1s again. And if I say no, now, if I edit the pad template, it might be this is where you have to get it. Let's see. Huh. No, that's not. What is it? Basically, what you can do and what I was looking for is you can use like a roadway template for the actual pad design itself. It's not from that. I don't think. Check and see. It might be all in. Here's a design pad. And let me try it from the takeoff method. That's a slightly different command. Perpendicular. Draw direction. Huh. I don't see it there either. Well, I will research that. It's basically, let's say this is a parking lot, and I could take that and not just create that as a flat pad, but I could tell it I want to use the shape of my curb, and I would define the dimensions of the curb, and it would push that curb all the way around that edge and make that part of that surface. All right, I'll research that over the break and see if I can find it. If not, there's other ways of doing it. I could, use field to finish or something like that. I'll survey to have it done. But it's really kind of helpful if you've got a design that the curbs are supposed to be fairly uniform. And even if it's got curb cuts and handicap ramps and things like that in it, you could still model it as a 6-inch, up and back type of curb, and then go through and model those areas independently for the ramps. But there's a way of doing this with design pad template. I've done it before, unless I'm confusing it with my other software, and I don't think I am. So I'll look that over at the break. So we're a good bit past our break point here, but let's go ahead and take us our 15 minutes. We'll come back at 5 till, and then we'll go to 4:30 or as long as we need to get everybody completely worn out. So I'll see you guys back at 5 minutes till, and I'm going to run the recording. So here is what I've done is something slightly different. I've sort of made this into a parking lot for us. And this has a particular elevation. I'm going to give this a, let's see, let's make this elevation 1309 to sort of match where it touches down right there. And now I'm going to go to my 3D data menu, and I'm going to use my elevation editor. I'm going to choose this polyline here now, and it's all flat at 1309. So I'm going to set this as a control and the end as a control. And I'm going to set these corners as controls. So there's one there. There's one here. One here, and then one here. And I'm going to put some variable slopes along this thing here. So now, going back up, so between the first one and the corner up here, I'm going to give it a slope coming in of, let's say, 3.5%. And then I'll go to this next one, and I'll make that one a little flatter. Let's call that, say, 2%. Go to the next one here, and let's make that one flat across the back. And then go to this guy and give it, let's match the same elevation as 0.16. So we'll give it an elevation here instead with 1311.323. And I'm just looking over here on the side of the screen and getting that elevation there. So now I've got some elevations, and so 1309 comes up, goes flat across, comes back down, comes back around. I'm good with that, and I'm going to say apply and close. If I look at that in relation to everything else going on here, I can see that, okay, I'm basically down there on the ground. I'm coming up, and you can see, let's turn off these. Where's my other? There we go. And let's give this a bit of an exaggeration so you can see the fact that it's let's do this so you can see it here on the screen. All right, so there you can see it starts down there at the bottom of the hill, comes up to that corner, which comes on up to this back, to that back corner over here, comes across flat, comes down and comes back around. So that's, maybe a little parking lot edge for us, okay? Now, I don't know which direction this is done. That's going to have some play into what we do. We'll take a look at it and see. If we need to reverse the direction, we can choose this. So if I go this way, it's now going that direction. It starts here, comes around to there. Let's put it back like that. So there's my first point. So it's created in that direction now. And I want to make a template for this to follow. So I'm going to go to I'm in the civil module now, and I'm going to go to, and you would have it if you're in construction, you would have it under your roads menu as well. We're going to do a design template. I'm going to choose new, keep it in our work area here, and I'm going to call it PKLT for parking lot dash curb and gutter. Okay. So now I've got a curb and gutter, and I'm going to uncheck the same as left. And I'm going to start with this line. That's the line I'm going to be walking around. I'm going to put a grade on that line. and it's going to be flat across, and it's going to go a distance of 1/2 foot. And that's going to be my top of curb. Okay, I'm going to add another grade now. And that's going to be a vertical difference of -1/2 foot for a horizontal different distance of just a little bit, just 1/10. I'm going to call that face of curb. Oop, I think I did that wrong. Let's see, we're going, actually, I'm on the left. I need to, actually, I'm going to move this over to the copy left to right, and then I'm going to take these guys out. Yeah, I'm sorry. I should have been. All right, so I'm doing here. I'm going here. Actually, let's see if I'm walking up the line. No, I'm building it to my right. Actually, I'm gonna, oops. All right, I need to be building it on the left anyway. So let's start that again. All right, slope of 0, horizontal distance of 1/2 foot. That is my top of curb. There we go. Now I'm going to add another one, which is going to be a vertical distance of -1/2 foot for a horizontal distance of 0.05. That's my face of curb. And I need to move that up. There we go. There we go. So there's the line I'm walking. I'm going to come over here to top of curb, bottom of curb, and I'm going to come down here now, add another grade. And this is going to be a percent of, say, a +4% for a distance of 1.5 foot. And this is going to be my gutter. All right, so it's going to look like that. All right. Now, on the back side of this, I need to add cut and fill. So I'm going to display nothing on the left. I'm going to establish a cut. So this is going to be that outside cut, that ratio of 6:1. So I'm going to say, see on the left side, uncheck that. The right side is going to be a ratio of a 6:1. And I'm also going to do a fill on the right-hand side of 6:1. So it's covered both conditions. Now I can see if that's the case, if I'm in cut, if I'm in fill, it's going to look like that. Okay. So that's going to be my template. I'll save that and exit. And now when I do design pad template, from my surface menu, design pad template, and here's what I missed. I don't understand how I missed this, but here's what we're going to do. Instead of ratio, we're going to use a template. Okay. And remember, we drew this as if we were walking up the line. We drew the curb to our left and our cut and fill to the right. So I'm going to say, okay. And it wants me to pick the polyline. There it is. Pick my target surface, which is that existing ground. Select the template. There's my template that I built. And here's what happened. Let's see what happened. Let's view this in 3D. I think I got my cut and fill. Let's put this back to a 1. So you can see it built the curb structure, but it did the cut and fill on the wrong side here, so let's go back to my roads design template and let's edit that template and fix that. All right, so no, that should have been,
Is it because it's in the left surface and it needs to be in the right surface since the lines are going up the direction?
no, not really. Let's see. Let me see if my cut, did I choose left? Right side same as left. See, I wanted the right side to have the cut fill, nothing on the left. And that displays correctly there. And if I look at the fill condition, that would work. That, so why? See, I don't see here. Let me try setting this right side same as left for my fill, right side same as left. That shouldn't be what I do. So my right side shows I guess I gotta put it in now. Over here on the left. Then all right, so it's all here on the left. I don't think if that's the case, that's going to be a little odd. I'll make sure that I erase previous pad. Okay, so slope template, slope direction. So, okay, slope direction. Go here. Now, why does it target to the inside instead of the outside? When I told you it was supposed to be easy here. That's the pad. What do I tell it? It's not prompting me for a side. If it were closed, I wonder. See, it should prompt me for a side. Try this. All right, now redesign that template again, put it where it's supposed to be. Cut is not going to be right side same as left. This should be nothing. That should be 6:1. Set from outside grade. Here we go. Tie to set. Tie to slope and series. Tie to set. Offset. Offset from the outside grade. No, from the center line. All right. Let's see if that does it for my cut. And my fill would be uncheck this, take this back out, leave that there. We're going to go from the center line, not from. So there it looks in fill, there it looks in cut. So I save, exit, maybe that would do it. And if I erase this now, make sure we're going in the right direction. There we go. Now back to design pad, everything the same. We choose our pad polyline, we choose our surface. Oops, yeah, that one. We choose our template. No, still doing it. This is now closed. Let's see what happens. We do a closed. Go to the outside. Yeah, apparently it didn't like the fact that it was unclosed, so it had to come up here and get rid of this stuff. So I'm going to get rid of that. That. Get rid of these things. Plus here to here. Now use that to trim. Now get rid of that. Get rid of, oh, not everything. Save that. And get rid of that segment too. Don't need it. Or that one. Okay, so now that's unfortunate. I'll run that up to Carlson tech support. That should not happen like that. But we've got a case here now where this pad polyline went to the outside. It had to be a closed figure if it's going to use that template correctly. But now when I view that, you can see, oh no, I see what happened. My gutter is outside of my parking lot at this point. shoot. Let me undo. I think I got rid of that original pad polyline. There we go. Now let's take this guy back out. All right, so this guy is walking away up here, so the curbing should be to the left. Ah. It may have worked just like it was supposed to work, and I just didn't know. All right, so the curbing, well, the curbing's to the left. That's my center. I go to the left, I go to the left, I go to the left. And in my cut, I'm going from offset from the center line tie. It's okay for that. And fill, let me uncheck that. All right, that should. Using the template. Yeah, still doesn't know. That time it made the curb and gutter on the correct side, but it put the extension, or it put the cut and fill slopes to the inside. So if I close this, and rerun it. No, see, it put the whole thing out there, the entire curbing. Go to the inside. And it put it on the inside, including that out slope. Let's see, right side, same as left. 6. Six. All right, so now on the right, it's in cut. All right, it doesn't matter. That's just for display. Now let's see if we get rid of this. All right, let's say okay. Pick our pad. Pick our surface. Pick our template. Oh, man.
What does that look like in 3D? Is it because your grade point is like the top of your pad there and you're coming down in elevation, like you're going flat across for your curb and then coming down, and then it has to rise back up to hit that pad
Well,
after it makes that curb?
it shouldn't be.
Because what
We'll
does
take
the
a
design pad template look like? Because your center line is the grade off the edge of your pad, right?
Yeah, that drawn pad should be my center line.
Yeah, so are you coming like across to the left flat for the top of your curb and then down for the front face of it?
And if I go to the outside this time, all right, so now you see the cut and, well, this outside line, if you look at this in our 3D, I don't think it's working correctly. You see what it did was it walked so you can see that blue line, that's my edge, but it pushed everything to the right. And I don't want it to go to the right. I want it to go to the inside with the template. So here's what I think is happening is in the case of this closed polyline, it forces everything outside from that center line out. It took the entire template out and then it attached the cut and fill to the end point, the last grade point instead of back here. So there's a couple of ways that we can do that. Let me fix it. I don't know why it's doing this, but here's what I would do to resolve this. I'm going to use that, and the direction I'm walking is the direction the template should get built. So when I look at my template, see, I'm walking this line. So I should come to the left, and come to here. Unfortunately, when I do cut and fill, you see, it always goes to the outermost edges. To do that, there should be, see, I should tie to existing section point. It's not the existing section point. Let me see that. Use cut to define cut slope treatment when the outermost point of the template is below, of course, or above. Cut slope or fill slope, right side same as left. Pivot at subgrade, smooth slope and series repeat slopes. Cut to, in addition to the bench. And that's the depth. Tie to, when enabled, this option will tie the cut slope from the cut pivot point, the outermost offset elevation from the existing section. See, I'm not using the section. Tie ID, indicate the desired ID. Okay. Tie to set offset. It forces the cut slope catch point to a specified fixed offset. This can be relative to the outside grade or to the center line. So the offset is determined from the center line. It can be used when you want the slope to always tie. And a fixed, oh, okay, that's just forcing it to intercept at a certain distance away. That'd be the very same thing. All right, so there's nothing tied to existing section point, no. So it's always going to go from the outermost grade. And in this case, if you say right side is the same as left, then it should pick, that's the outermost grade of this template. So what I would do in this case, since that's not working the way it should work, is I'm going to take these off and we'll just build the geometry. Go from here to that surface. No, okay. Let's undo. Instead of targeting a surface file, I don't want an elevation either. Dump. So it's always going to go to that outermost. What if we did this? There now. No, I need to take my gutter back down. Yep. And I need to insert the back of curb. So I'm going to add a grade from the center. Let's see. My top of curb. Move that up. All right, that's exactly what I want. To build the curb, but I don't want it to catch from here. And even if I don't have a cut and fill, it's still going to try to target that surface. So if I did this, if I moved all of that over and get rid of this and this and this. And now let's bring this guy up and this guy. Just to go. Let's try that. Oh, crap, see? All right, so that would be what I want to see. All right, so I've drawn it sort of mirror image to what I want. Target that surface to use that template. Now, see, it still pushes it still always pushes the curb out, and then it puts the tie slopes on that outermost edge. All right, so what I would do then is this. Let's take him out. It's still going to wherever it set my grade 0, a distance of ½ a foot, top of curb, then add a grade of vertical of -½ a foot for a distance of just a skosh. That's face of curb. And then I want to add a positive 4% for a 1.5 feet as my gutter. Yeah, see, it's still going to try to tie to the ground. So if I design pad template, is there a place to tell it to unhide? Not really. So if I select this, I got to give it a target surface. Might be able to yeah, so we would have to go through here and let's isolate this layer and let's erase all of that. And then it's not a very efficient way of doing this. I've got to figure out what's going on with that. All right, so now when I look at that 3D, that now has built my curb structure the way I wanted. And now we've got a straight line out there. do something like get rid of these. And then with the 0 radius, this to this. Oh, they're 3D. All right. Corner. Radius of 0. I'm still not going to do it. Let's see. Well, what I would do then is simply get rid of those. Take this guy out until he intersects here. Do the same thing with this guy. And then use these to trim. And I'm going to trim that and that and that and then that one twice. And then you can join those back up. And then that would be your curb structure. Let's see, let's now join that. Looks like it's all the way around. All right, so no need to. All right, so it's intact. And so then what I would do is run another pad polyline, or design pad template rather, target the surface, use a ratio, do not erase my previous, say okay, and I'm going to pick this pad polyline, target that surface, go 6:1s on this outside. Ah, did you see that? I picked that side. Okay. Surface file should be okay. Pick the pad polyline here. My target. 6:1, 6:1. Pick a side. There we go. I must have, for whatever reason, was out of whack with it. I'll now view that. And there now would be that lovely little parking lot tied into the existing ground. Just a couple of fill corners, everything else is cut down into it. And I could use that to then make a surface out of this, call it my parking lot. And then I could do the same thing. I could just draw in my islands, lay them on that surface. And remember, that surface has a slope to it. So if I triangulate and contour this, call it, my PKLOT. Oh, sorry. Now what I need to do is this time tell it to shrink wrap. I got a little bit of a mess up in here. Oh. Get rid of that. And since that is a closed polyline, that's what I needed to have done. Try to call it triangulate and contour, use the inclusion this time. Oop, it's not closed. It says it's, oh, I see, it's closed around there. So if I, let's draw the shrink wrap. Draw it again. Except give it a height reduction. Still had a problem. I'm going to fix that right here. And I'm going to make that object current. I'm going to draw a 2D polyline by continue. I'm going to continue this line. And I'm now going to follow this line. And the first follow point will be right there. And the last follow point will be right there. Oh, interpolate. No, I'm going to follow my last point to right there. Is that correct? Yes or no? And you could say, you can see it follows around the other direction because it's closed. I'll say yes. And done. And now I've got a boundary that I can use. So if I triangulate contour this time, choose that as my inclusion. No oops, use inclusion. There we go. Yes, and let's choose that. No X, says it's not closed. Of course. Choose that, and that, that. Okay. It's now closed. Use inclusion. There's the closed polyline, no exclusions. Now take the data. I do have a couple of vertical edges. Right in there, they didn't match up. I'm just 0.02 of a foot off. I'm going to ignore that one. Same thing with that one. It's where I tied these out. I needed to have actually snapped the point. Do the end point. Should now work for me. It did. Here is now the resulting surface. Turn that off. You can see the triangles. Including the curb and gutter, which you can see there. And we can also see the contours. You see, it's not a flat. Now, right in here is a case where you got those jiggy jaggies, and you could lay in some points, some lines across that from the curb face to the curb edge to the curb edge, have them densify it, and then rebuild that surface, and you'll smooth those out. We won't go through that effort. Some people like to do this where you, if you're editing the surface with the editor, you're going to swap thin edge, and here's what happens. Let's just display these. So if I swap this 10 edge, you see I took that one out. So you can sort of, you know, like I said, you wind up chasing your tail all day long trying to do this. So it's not a very efficient way of doing it. So we're not going to go through that. But so what I would do in this particular case, because of those jiggy jaggeds, I would lay in some line work, edge to edge, elevate them, and then rebuild that surface. For instance, I would do just a 2D poly. Use a 3D break. And we'll go from that point to that point. And what is that distance? I think is 10 feet. So I would then just copy that down to each of these little, oops, nubby points. I missed that one. I'll go back and fix it. As I'm just hitting all these little endpoints. It's that one too. I'm going to move it from that endpoint to that endpoint. I'll do the same thing here. From there to there. Right now, I've got some things that I'll rebuild that real quick. Triangulate and contour. I'm going to make sure I've got my densify on, and I'll put that, I'll just match it to 10 feet. Okay, overwrite. I'll find this. No exclusions. Got all my data. Nope, I did something wrong. I didn't elevate those lines yet. See, and that's one thing I should have checked. I want to do a 2D to 3D by screen entities. So I'm going to take all of these and I'm going to elevate them by that inside edge. All right, now. We find that, no exclusions, and now when we do it, we wind up with a vertical edge of something here. Aha. So what happened there was this guy needed to have been erased, and we missed it the first time out. And since that is now set there, let's set that back. 2D to 3D by screen entities. I forgot which one I was working on. Let's just do both of these by that. Okay. Final bit. Inclusion, no exclusion. Get the data. Still give me a vertical edge. Where was it? That upper one. Okay. Is there a little nubbit left? No. that did not get elevated. Actually, it should have. None of those are 3D. Let's see. That's a 3D. Okay. So let's do 2D to 3D by screen entities. Say, okay, we'll take all of these and let's just grab everything. So whatever it crosses, it's there. Let's verify. Looks good. That now should work. He said famous last words. So we'll set this, grab our data, and now we should have it. We do. We now have a surface to look at, to verify, and why did it not use those as break lines? One more try. Did I densify? Yeah. Oh, 100. Let's make it 10. And that, and then use that. And now. Yeah, that's what I was looking for. So when I can spin that guy up, I see I messed up that corner with those elevations in there, but you can see I got rid of the squiggles on the contour lines. Except for in here, I might needed to have added some in there, but that's basically the process. Not, excuse me, not entirely necessary that it's done that way, but you get the idea of what you can do with these tools and some of the things you have to go through and start to visualize and check. So here's a case, I've got the curb structure is showing up very nicely. If I come out here and actually add this stuff in, you can see, oh, I see, yep, everything looks all right there. So you've got a little bit of squiggles out in here. You might densify that up instead of every 10 feet, make it every 2 feet or 5 feet. And, help make those a little bit nicer. Okay. So that puts us a little bit beyond. We'll give you an extra half-hour credit on the PDHs, but that's sort of what we would go through. And I might even see, I went from edge to edge across here, and that really shouldn't be there. You see how it's messed this up? So I would probably take that, go back through and peel a few of these back off. Or I might even decide to, if I crossed them this direction, not sure. Various things that you can do to try to help define this a little better. Okay, so that's basically sort of the grading type of exercise to set those in. And then once that's built, you can then create that as a surface. Now, if you do that under your SiteNet stuff, where you then change your design to, instead of looking at layers, you look at a file and you load that file. Now, here's the problem with that, is that it would only be this one file. So you would have to do all of your design work and build it as a total file for everything and then look at it. Or you can do all this stuff in piecemeal fashion using the SiteNet menus as well. Just do them at each individual one, set your individual parameters, and you get your costs and your materials for each of those little sub areas. or you would use triangulation file utilities, merge these designs into the existing ground and call that overall total product the finished grade, set that in as your file to use in that design tab. And then it would take everything across the entire site. All right. So when we come back tomorrow, then what we're going to take a look at is we're going to go through the little tutorial on that site with the building. There's all kinds of things that look at various aspects of what you need to do, like elevating curb lines based on elevation labels, setting in building pad thicknesses and subgrades and accumulating your materials. All of those kinds of things that you would typically do. Also, we go out in the tutorial, it only say went out to this back edge of the furthest paving. We're going to want to go from there and establish this line out here because we want to tie that in to our existing grade. We don't want to leave it sticking up in the air or sticking down in a hole in the ground. So we'll do that part of it and you can get an idea of how that total process should work. We'll also take a look at some of the, I've got some other files that I've put together. You have them in your system. You can load them up and look at them at will, but we'll take a look at some of those and what I went through to develop those different things. And they were done for an excavator that wanted to put his bids together. So we went through and built his surfaces, took them from PDF files, and there was a lot of editing going on because you had to tie together a lot of those contours and get rid of, he had some hatch patterns that were unfortunately all on the same layer. We had to go through and make sure we got rid of all the little symbols that came out of the hatch pattern, different things like that. But we've got some things in stages that you can take a look at and see how that works. So we'll take a look at that and see that process come tomorrow. So any questions to this point beyond why the hell doesn't that template work? And that's a question I've got for Carlson. In fact, if you take a look at, oh, sorry, that's not the one I want. It's design pad with a civil template. Here's what they put together. Let's see if we can stop it. See if we go a 2-minute video.
In a prior video, we introduced you to design pad template. The results are in the lower left corner. This time, we're going to add a layer of complexity by using a template that we created in Civil to attach to our shape and tie into the existing ground and use the rules in the template. So here we're going to pick our polyline, we're going to pick the existing ground, and then we're going to pick this curb template and attach it.
I didn't hit it quick
To
enough.
pick this curb.
Now that's what I wanted to look at, and I see his curb. He's got the cut and fill coming from, oh, I see. I see entirely. He's actually building the 3-dimensional structure. I only went across the top edges. So he built the entire 3D structure using a curb. That may be the difference. I'll give it a try.
And attach it to the line. Watch what happens as we do this. We're going to put in a pad elevation here in the middle of the range again, like we did on the introductory one. And immediately again, it does what it's supposed to with projecting slopes and calculating volume. But let's take a look at the results in the 3D viewer here. And what you're going to see is that we've added this layer of complexity by putting in.
So right there, he got the cut and fill that went to the outside. Now that may have been because he was using a closed polyline and he went to the outside, and that therefore it did not do anything out here. I'll give that a try and see, if we can.
Gutter attached to that line automatically, and it followed the rules of the template as far as how it tied into the existing ground.
So that is how they demonstrate that, and it's with a closed rectangular shape. I'm still going to try it with mine with open, and I'll see if I can't use the actual curb itself to establish that as a structure, and that might make the difference, in which case there's no reason it should. What we were doing should have worked. But I'll track that down. No need to sit and have you guys watch me fumble around with that. Okay. So let's go ahead and call it a day. We'll see you guys back. I'll send you later, either later tonight or sometime before class starts in the morning. You'll get an email with the link for tomorrow's session, and we'll be good to go. And before we go, though, any questions to this point that can't wait?
Nope.
Everybody good? All righty.
Good.
Yes, sir.
Yep.
All
right.
Thank you very much, Ken.
Absolutely. I'm going to stop the recording. This